Hello there, and welcome. Tonight I want to take you somewhere special, somewhere beyond the familiar walls of your room, beyond the gentle glow of whatever screen you're watching this on, beyond even the soft boundaries of Earth itself. I want to take you into a question so vast, so quietly profound, that it might just change the way you feel about existing in this very moment. It's a question that at first might seem impossible, even absurd, but as we explore it together, slowly, gently, like walking through a garden at twilight, you might find it becomes not just possible, but perhaps even necessary. What if the universe, this grand cosmic home we all share, never actually began? What if there was no first moment, no initial spark, no primordial awakening from nothingness into being? And stranger still, what if this beginningless universe doesn't lead to a single ending, but to many scattered across the infinite expanse like seeds of possibility, each one unique, each one final in its own way, yet none of them truly the end of everything? I know how this sounds at first. We are creatures of beginnings and endings, you and I. Every story we've ever heard starts somewhere and concludes somewhere else. Every day begins with the sun rising, or at least with us opening our eyes, and ends with darkness falling, with our consciousness gently dissolving into sleep. Our very lives have clear starting points. That first breath, that first cry, and we know, though we don't often like to think about it, that they will have endings too. So the idea of a universe without a beginning feels almost like a violation of the basic rules we've come to understand about how reality works. And yet, as we'll discover together tonight, this seemingly impossible idea has been seriously considered by some of the brightest minds in cosmology, physics, and philosophy. It's an idea that emerges not from wild speculation, but from careful observation of the cosmos, from mathematical models that describe reality with stunning precision, and from a growing recognition that our human intuitions about time, about causation, about the nature of existence itself, might be far too limited to capture the true character of the universe we inhabit. Before we go any further, let me ask you something, and I mean this genuinely, as if we were sitting together under a vast night sky, perhaps on a hillside far from city lights, where the Milky Way stretches above us like a river of light. Where are you right now? What corner of our planet are you calling home tonight? Is it late where you are, with the world outside your window settling into quiet darkness? Or perhaps it's that drowsy afternoon time when the day seems to pause and yawn. Maybe you're in a bustling city where the night never truly gets dark, where streetlights and neon create an artificial dawn that lasts until the real one arrives. Or maybe you're somewhere rural, somewhere where the night still means something, where darkness is real and deep and full of stars. Wherever you are, whatever time it is for you, I'm glad you're here. And if you're finding this journey into cosmic mysteries as fascinating as I hope you will, perhaps you might consider subscribing to hear more of these nocturnal wanderings through the universe's deepest questions. A gentle light helps these ideas reach other dreamers and wanderers, other souls who find themselves awake at odd hours, seeking something more than the usual distractions, seeking perhaps what you're seeking right now, a sense of connection to something vast and mysterious and beautiful. We're building a quiet community here, you and I and others like us, people who find comfort not in having all the answers, but in knowing that the questions themselves are profound enough to hold us, to cradle our curiosity as we drift towards sleep. The question we're exploring tonight, this idea of a universe without beginning but with multiple endings, touches on some of the most fundamental aspects of reality as we understand it, and perhaps more importantly as we don't yet understand it. You see, for most of human history, the question of the universe's beginning was primarily a religious or philosophical one. Different cultures had different creation stories, different myths about how everything came to be. Some imagined the universe emerging from chaos, others from the breath or word of a deity, still others from the breaking of a cosmic egg or the dreams of a sleeping god. But in the last century, something remarkable happened. We began to find actual evidence about the universe's deep history, written not in ancient texts but in the light of distant galaxies, in the whisper of radiation that fills all of space, in the precise abundances of the lightest elements. This evidence seemed to point toward a definite beginning, a moment roughly 13.8 billion years ago when the universe was incredibly hot, incredibly dense and incredibly small, a moment we've come to call the Big Bang. But here's where things get interesting, where the story takes a turn that even many scientists find surprising. The Big Bang, despite its name, might not actually be the beginning of everything. It might instead be something more like a transition, a transformation, a doorway between one phase of the universe's existence and another. Think of it this way, and let this image settle gently in your mind like a leaf falling onto still water. Imagine you're watching a river, following it upstream, trying to find its source. You walk for hours, days even, moving against the current, and eventually you come to a waterfall, a dramatic cascade where the river tumbles down from some higher place. Now, if you could only see the waterfall and nothing above it, if clouds or mist obscured everything beyond that point, you might reasonably conclude that the waterfall is where the river begins. But of course, the river continues above the waterfall, perhaps for hundreds of miles, perhaps fed by countless streams and springs, perhaps even connected to other rivers in ways you couldn't imagine just by looking at that one dramatic transition point. The Big Bang might be like that waterfall, a dramatic transition that obscures our view of whatever came before. Our equations, our theories, our observations can trace the universe's history back to that moment of incredible heat and density. But when we try to push further, when we try to see what came before, our usual tools break down. The mathematics becomes undefined, like trying to divide by zero. The physics becomes uncertain, with quantum effects and gravitational effects becoming equally important and deeply intertwined in ways we don't yet fully understand. It's as if the universe has drawn a veil across its deeper past, challenging us to find new ways of thinking, new mathematics, new physics that can penetrate that veil and reveal what, if anything, came before. And this is where our journey really begins to get interesting, where we start to move from the familiar territory of what we know into the misty borderlands of what we might discover. Because in recent decades, physicists and cosmologists have begun to develop new theories, new models, new ways of thinking about the universe that suggest the Big Bang might not be the beginning of everything, but rather just the beginning of the universe as we know it. Some of these theories suggest that the universe goes through cycles, expanding and contracting, dying and being reborn, over and over again through eternity. Others suggest that our Big Bang was just one of countless similar events happening throughout a vast, perhaps infinite multiverse. Still others propose that time itself might not be what we think it is, that our perception of a flowing sequence from past to future might be a kind of illusion, and that in some deeper sense, all moments exist simultaneously in what physicists call the block universe. Let me share something with you that might help make this feel less abstract, less like pure intellectual speculation, and more like something you can almost touch with your imagination. Close your eyes for a moment, or if you're already lying down, just let your gaze soften and unfocus. Imagine you're floating in space, but not the space near Earth with its familiar blue marble and silver moon. Imagine you're floating far out beyond the most distant galaxies we can see, in that vast darkness between the great clusters and superclusters of galaxies. It's quiet here, quieter than anywhere on Earth could ever be. There's no air to carry sound, no nearby matter to create vibration. The silence is absolute, perfect, eternal. And in this silence, you can somehow sense the great slow breathing of the universe itself, the expansion of space that carries galaxies away from each other like leaves on an expanding pond. Now imagine you have the power to perceive time differently, not just the normal flow from moment to moment, but deep time, cosmic time, billions of years passing like heartbeats. You watch galaxies form from vast clouds of hydrogen, their first stars igniting like countless candles being lit in a dark cathedral. You watch these galaxies dance around each other, sometimes merging in slow, graceful collisions that take hundreds of millions of years to complete. You watch stars being born and dying, some exploding as supernovae, scattering the elements they've forged in their cores into space, where they'll become part of new stars, new planets, perhaps new life. And as you watch all this, as you observe billions of years of cosmic evolution, you begin to notice something strange. The expansion of space isn't slowing down as you might expect if the universe had been given an initial push at the Big Bang and was now coasting. Instead, it's speeding up, accelerating as if some invisible force is pushing everything apart faster and faster. This acceleration, discovered just a few decades ago by astronomers studying distant supernovae, was one of the most shocking discoveries in the history of cosmology. It suggests that the universe's future might not be what we expected, might not be a simple continuation of what we see today, and if the future can surprise us, perhaps the past can too. Perhaps our assumption that the universe must have had a beginning is just that, an assumption based on our limited human experience rather than a fundamental truth about reality. After all, we've been wrong about cosmic fundamentals before. For most of history, humans thought Earth was the center of everything. Then we learned we orbit the Sun. Then we learned the Sun is just one star among hundreds of billions in our galaxy. Then we learned our galaxy is just one among trillions in the observable universe. Each time, the universe proved to be vastly larger, vastly stranger, vastly more magnificent than we had imagined. Why should we assume we've finally got it right when it comes to understanding the universe's beginning, or lack thereof? Consider for a moment the profound shift in perspective this represents. If the universe had a beginning, then everything we see, everything we are, emerged from that singular moment. We can trace our atoms back to stars, stars back to the first generation of stellar formation, and that back to the Big Bang itself. It's a linear story, a clear narrative with a definite starting point. But if the universe had no beginning, if it has always existed in some form or another, then the story becomes far more complex, far more mysterious. Where did the patterns come from that led to galaxies and stars and planets and life? How can something have always existed? What does always even mean in this context? These questions don't have easy answers, and perhaps that's part of their beauty. They invite us to expand our thinking, to question our assumptions, to remain humble in the face of cosmic mystery. And speaking of mystery, let's talk about those multiple endings I mentioned at the beginning. This might seem even stranger than a universe without a beginning, but in many ways, it follows naturally from what we've been discussing. You see, if the universe is infinite in extent, as many cosmologists now believe based on observations of the cosmic microwave background and the large-scale structure of galaxy distribution, then it might not have a single unified ending. Different regions of this infinite cosmos might evolve differently, might reach different final states at different times, or perhaps at the same time but in different ways. It's like an infinite library where every book tells a different story, and while each book has its own ending, the library itself has countless endings, one for each book, each one unique and final in its own way. But even if the universe is finite, even if it's closed and bounded like the surface of a sphere is bounded, even though it has no edge, it might still have multiple endings in a different sense. Modern physics suggests that quantum mechanics, the strange and beautiful theory that governs the behavior of atoms and subatomic particles, might apply to the universe as a whole. And one of the key features of quantum mechanics is that it deals in probabilities rather than certainties. An electron isn't in a definite place until you measure it. Instead, it exists in what physicists call a superposition of all possible places it could be. Similarly, the universe's future might not be a single predetermined outcome, but rather a superposition of many possible futures, each with its own probability, each representing a different possible ending to the cosmic story. This idea becomes even more intriguing when we consider the possibility of the multiverse, the idea that our universe might be just one of many, perhaps infinitely many, universes existing in parallel or in sequence or in some other relationship we can barely imagine. Each of these universes might have its own ending, its own final fate, determined by the particular values of physical constants, the particular patterns of matter and energy, the particular quantum fluctuations that shaped its evolution. From this perspective, asking about the universe's ending is like asking about the ending of all possible stories. There isn't one answer, there are countless answers, each one true for its own cosmic narrative. As we continue our journey tonight, we'll explore these ideas in much more detail. We'll look at what physicists and cosmologists have discovered about the nature of time itself, and how these discoveries suggest that our everyday understanding of before and after cause and effect might be far too simple to capture the true nature of temporal reality. We'll examine the evidence written in the cosmic microwave background, that faint afterglow of the Big Bang that might contain hints of what came before, if anything did. We'll journey to the far future, trillions of years from now, when the stars have all burned out and the universe has grown cold and dark, and we'll ask whether this is truly the end or perhaps just another transition, another transformation in an eternal cosmic dance. But for now, in this moment, I want you to simply rest with the possibility we've opened up together. Let it settle into your consciousness like starlight settling onto a quiet lake. The universe might have no beginning, it might have multiple endings, and here you are right now, a conscious being capable of contemplating these vast ideas, a collection of atoms that has somehow become aware of itself and its cosmic context. In a universe without beginning, your existence is no less remarkable, no less precious. In fact, it might be even more extraordinary, a brief flame of awareness in an eternal darkness, a moment of questioning in an infinite expanse of being. The gentle paradox of our exploration tonight is that the more we expand our perspective, the more we zoom out to contemplate the universe in its totality, the more we can appreciate the profound significance of this very moment, your very moment right now. Because whether the universe began or has always been, whether it will end once or many times or never truly end at all, this moment, your experience of it, your awareness reading or hearing these words is real and unique and irreplaceable. In an infinite cosmos there might be other beings somewhat like you, other moments somewhat like this one, but there is only one you, only one now, only one instance of this particular consciousness, encountering these particular ideas in this particular way. As we prepare to dive deeper into our cosmic contemplation, to explore the nature of time itself in ways that might challenge everything you thought you knew about past and future, beginning and ending, I want to remind you that this is a journey we're taking together. You're not just a passive recipient of these ideas, you're an active participant in this exploration. Your mind, as it processes these concepts, as it perhaps resists some and embraces others, as it forms its own images and connections and questions, is doing something profound. You're not just learning about the universe, you're the universe learning about itself. You're the cosmos becoming conscious of its own mystery, its own vastness, its own beautiful uncertainty. The question of whether the universe has a beginning is ultimately a question about the nature of existence itself. Why is there something rather than nothing? How can anything exist at all? And if something exists, must it have come into existence at some point, or could it have always been? These are perhaps the deepest questions human beings can ask, questions that touch on the very foundations of reality, meaning, and our place within the cosmic order. Different philosophical traditions have approached these questions in different ways. Some have argued that existence requires a cause, a prime mover, a necessary being that brings everything else into being. Others have suggested that existence might be its own explanation, that asking why there is something rather than nothing is like asking why mathematics is consistent or why logic is logical. The question contains a category error that makes it unanswerable. Modern cosmology offers us new ways to approach these ancient questions, not necessarily to answer them definitively, but to refine them, to understand better what we're really asking when we wonder about the universe's beginning. For instance, when we talk about the universe beginning, we usually imagine it appearing within some pre-existing framework of space and time. But general relativity, Einstein's theory of gravity, that has passed every experimental test we've thrown at it for over a century, tells us that space and time are not fixed stages on which cosmic drama plays out. Instead, they're part of the drama itself, woven into the very fabric of the universe, capable of bending and stretching and perhaps even coming into or going out of existence. This means that asking what came before the Big Bang might be like asking what's north of the North Pole. The question assumes a framework, a coordinate system that might not apply. If time itself began with the Big Bang, then there was no before in any meaningful sense. There was no empty time waiting to be filled with universe. There was simply nothing, not even emptiness, not even waiting. And then, somehow, there was something. Space and time and matter and energy all emerging together in a cosmic symphony that has been playing ever since. But this picture, as mind-bending as it is, might still be too simple, because quantum mechanics suggests that even nothing, even the absolute vacuum of empty space, is not really empty. It seethes with what physicists call quantum fluctuations, particle-antiparticle pairs popping into existence and annihilating each other so quickly that they can't be directly observed. These fluctuations are not just theoretical, they have measurable effects, like the Casimir effect, where two metal plates placed very close together are pushed together by the pressure difference between the fluctuating vacuum outside and the restricted fluctuations between the plates. If even nothingness is so active, so pregnant with possibility, then perhaps the emergence of something, even something as grand as a universe, is not as surprising as we might think. Some physicists have proposed that our universe might have emerged from just such a quantum fluctuation, a particularly large and long-lived bubble in the quantum foam that managed to inflate and evolve into the cosmos we see today. This wouldn't necessarily mean the universe came from nothing in an absolute sense, because the quantum vacuum with its fluctuations and its physical laws is already something. But it would mean that universes might emerge naturally, spontaneously, without need for any external cause or creator. They might be as inevitable as bubbles in boiling water, each one a separate world with its own space and time, its own beginning and ending. This brings us to an even more radical possibility, one that some cosmologists are now taking seriously. Perhaps universes don't just emerge once, but continuously, eternally, in a process called eternal inflation. In this scenario, the quantum field that drove the rapid expansion of our early universe, the inflation that smoothed out irregularities and made the cosmos remarkably uniform on large scales, never completely stops. In most regions it does stop, creating pocket universes like our own, where inflation has ended and normal cosmic evolution can proceed. But in between these pockets, inflation continues forever, constantly creating new regions of space, new potential universes, in a fractal pattern of endless creation. If eternal inflation is correct, and some versions of it are strongly supported by our observations of the cosmic microwave background, then our universe is just one bubble in an infinite champagne of universes, constantly fizzing into existence. Each bubble has its own beginning when inflation ends within it, but the overall process has no beginning. It is eternal, self-sustaining, a cosmic perpetual motion machine powered by the inherent uncertainty of quantum mechanics. And each bubble might have different properties, different physical constants, different laws even, determined by how the various quantum fields happen to settle into their ground states when inflation ends. This picture radically changes our perspective on beginnings and endings. Our universe had a beginning in the sense that there was a first moment of time within our bubble, a moment when inflation ended and normal cosmic evolution began. But this beginning was not the beginning of everything, just the beginning of our local patch of reality. Beyond our cosmic horizon, outside the bubble we inhabit, the process continues, has always continued, will always continue, world without end, or rather, worlds without beginning, each with their own endings, plural, diverse, infinite. As we contemplate these possibilities, it's natural to feel a bit overwhelmed, perhaps even a bit anxious. The human mind evolved to deal with human-scale problems, finding food, avoiding predators, navigating social relationships. We're not naturally equipped to grasp infinities, eternities, multiple universes. But here's something beautiful to consider. The fact that we can even contemplate these ideas, that we can use mathematics and observation and careful reasoning to peer beyond the limits of our everyday experience, is itself a kind of miracle. We are the universe developing eyes to see itself, minds to question itself, hearts to marvel at itself. And perhaps this is where the real significance of these ideas lies, not in the abstract philosophical or scientific implications, but in what they mean for us as conscious beings trying to make sense of our existence. If the universe has no beginning, then the mystery of existence is even deeper than we thought. We can't explain the universe by pointing to a moment of creation. We have to accept existence itself as a brute fact, a given, a mystery that might be beyond explanation. And if the universe has multiple endings, then the future is not a single predetermined story but a garden of possibilities, each path leading to its own destination, each ending as valid and real as any other. This might sound like it makes everything meaningless. If there's no single beginning, no single ending, no single story, then what's the point? But I would suggest the opposite. In a universe without beginning, every moment is equally miraculous, equally unlikely, equally precious. There's no special first moment that contains all the meaning. Instead, meaning is distributed throughout time, present in every instant, including this one. And in a universe with multiple endings, our choices, our actions, our very existence might play a role in determining which ending becomes real, at least in our corner of the infinite cosmos. Think about it this way. and let this thought accompany you as you drift towards sleep tonight. In a universe without beginning, you're not the product of a single creative act billions of years ago. You're the product of an eternal process, a timeless dance of matter and energy, space and time, that has always been creating, always been exploring, always been discovering new ways to exist. Your consciousness, your ability to wonder about these very questions, is not a latecomer to a universe that existed for billions of years without it. Instead, it's a manifestation of the universe's eternal tendency toward complexity, awareness, and self-reflection. And in a universe with multiple endings, your life is not just a tiny footnote in a single cosmic story that will end the same way regardless of what you do. Instead, your life is part of the process by which the universe explores its own possibilities, discovers its own potential endings, writes its own multiple conclusions. Every choice you make, every thought you think, every dream you dream contributes to the particular ending that will manifest in your region of space-time. You're not just a passive observer of cosmic evolution. You are an active participant in determining how the story unfolds, at least locally, at least for a while. As we move forward in our exploration, as we dive deeper into the nature of time and the evidence for what might have come before the Big Bang, I want you to carry with you this sense of wonder, this feeling of being part of something incomprehensibly vast yet intimately connected to your own existence. The universe's lack of beginning doesn't diminish you. It elevates you to the status of an eternal participant in an endless cosmic dance. The universe's multiple endings don't fragment meaning, they multiply it, creating countless stages on which the drama of existence can play out. We've covered a lot of ground already, you and I, and we're just getting started. We've opened the door to a universe that might be eternal, that might be constantly creating new versions of itself, that might end not with a single whimper or bang, but with a symphony of different conclusions playing out across infinite space and time. These are not easy ideas to grasp, and if your mind feels a bit stretched, a bit tired from trying to wrap itself around these concepts, that's perfectly natural. In fact, it's exactly what we want. Because as your conscious mind relaxes its grip, as it stops trying so hard to understand and control and categorize everything, your deeper mind, your dreaming mind, your intuitive mind, can begin to play with these ideas in its own way. Tonight, as you sleep, you might dream of universes being born from quantum foam, of time flowing backward and forward and sideways all at once, of endings that are beginnings and beginnings that never were. These dreams are not just random neural firing, they're your mind's way of integrating these vast concepts, of finding personal meaning in cosmic abstractions, of making the infinite feel intimate. And tomorrow, or whenever you wake, you might find that something has shifted in how you see the world, some subtle but profound recognition that reality is far stranger, far more wonderful, far more open to possibility than you ever imagined. But we're not done yet. Oh no, we're just beginning to scratch the surface of these mysteries. In our next chapter, we're going to explore time itself, that most familiar yet most mysterious aspect of our existence. We take it for granted that time flows from past to future, that causes precede effects, that yesterday is gone and tomorrow hasn't happened yet. But what if time doesn't really flow at all? What if past, present and future all exist simultaneously in what physicists call the block universe? What if the Big Bang is not the beginning of time but just a special location in a four-dimensional space-time that extends infinitely in all directions, including directions we call temporal? These questions will take us into the heart of modern physics, into the strange world where Einstein's relativity meets quantum mechanics, where time can dilate and contract, where the order of events can depend on your perspective, where the very notion of now becomes problematic. We'll explore how physicists think about time, how they model it mathematically, and what their equations suggest about the possibility of time without a first tick, without a starting moment, without a beginning. And so we continue, you and I, deeper into the mystery, deeper into the night, deeper into questions that have puzzled humanity since we first looked up at the stars and wondered about our place in the cosmic order. In our last moments together, we opened the door to a universe that might have no beginning, that might have always existed in some form, transforming and evolving but never truly starting. Now we need to understand what this really means. what it means for time itself to have no first moment, no initial tick of some cosmic clock, no primordial "let there be light" that set everything in motion. This is not an easy thing to contemplate because everything in our experience has beginnings. Every story starts with once upon a time, every journey begins with a first step, every piece of music emerges from silence. How can we even think about time without a beginning? How can we imagine a clock that has always been ticking? Let's start with something familiar, something you experience every day, every moment really. Time, as you know it, as you feel it, flows from past through present into future. You remember yesterday, you experience now, you anticipate tomorrow. This seems so fundamental, so obviously true, that questioning it feels like questioning whether you exist at all. And yet, this flowing time that you experience, what physicists sometimes call psychological time or subjective time, might be very different from time as it actually exists in the physical universe. Your perception of time is created by your brain, by the way memories are formed and accessed, by the thermodynamic arrow of time that points from order to disorder, by the countless chemical reactions in your neurons that proceed in one direction and not the other. But the universe itself, the vast cosmos beyond your skull, might experience time in a completely different way, or perhaps doesn't experience it at all. Think about this for a moment, and let the strangeness of it wash over you like a wave of cosmic perspective. When you remember last Tuesday, you're not actually travelling back in time to last Tuesday. You're accessing a pattern of neural connections in your brain right now, in this present moment, that encodes information about last Tuesday. When you plan for next Wednesday, you're not reaching forward into the future. You're creating patterns in your brain right now that represent possible future states. All of your time travel, all of your movement through past and future, happens in the present. It happens now. It always only ever happens now. The past is a present memory, the future is a present expectation, and the flow of time might be something your consciousness creates rather than something it observes. This is not just philosophical speculation, it's suggested by our best theories of physics. Einstein's theory of special relativity, which has been confirmed by countless experiments over the past century, tells us that there is no universal now that extends throughout the universe. Two events that appear simultaneous to you might happen at different times for someone moving relative to you. If you and I were moving at high speed relative to each other, we would disagree about whether two distant events happened at the same time or one after the other. We would literally have different nows, different present moments, different ways of slicing up space-time into space and time. This leads to a picture of reality that physicists call the block universe, or eternalism. In this view, the universe is a four-dimensional block of space-time, 3 dimensions of space and 1 of time, all existing together, all equally real. Past, present and future don't flow one into another. They coexist like different locations in space coexist. The Big Bang isn't something that happened. It's a location in space-time, like the North Pole is a location on Earth. The heat death of the universe billions of years from now isn't something that will happen. It's another location in space-time, like the South Pole. And this present moment, this now that feels so special and unique to you, is just your current location in the block, no more special in any objective sense than your current location in space. If this block universe picture is correct, and many physicists believe it is, then asking about the beginning of time is like asking about the edge of space. Just as the universe might be infinite in spatial extent, stretching forever in all directions, it might be infinite in temporal extent, stretching forever into what we call past and future. Or, just as space might be finite but unbounded, curved back on itself like the surface of a sphere, time might be finite but unbounded, curved in ways we can barely imagine. In either case, there would be no first moment, no boundary where time begins, no edge beyond which there is no time. But wait, you might be thinking, doesn't the Big Bang mark the beginning of time? Isn't that what cosmologists tell us? That time and space both began 13.8 billion years ago? Well, yes and no. The Big Bang certainly marks a boundary of sorts in our observable universe. As we trace cosmic history backward, we reach a point where our theories break down, where the universe becomes so hot and dense that quantum effects and gravitational effects become equally important, and we don't yet have a complete theory that can handle both simultaneously. This breakdown happens at what physicists call the Planck time, about 10^43 seconds after what we conventionally call time zero. Before the Planck time, our usual notions of space and time might not apply. The universe might have been in a state where space and time as we know them hadn't yet emerged, or where they existed in some radically different form. But this doesn't necessarily mean that nothing existed before the Planck time, or that there was no notion of before at all. It might just mean that we need new concepts, new mathematics, new physics to describe what was happening. And indeed, physicists have been developing such new approaches. String theory, loop quantum gravity, causal set theory, and other approaches to quantum gravity all suggest ways that space and time might emerge from something more fundamental. Something that doesn't have the properties we usually associate with space-time, but from which space-time can arise under the right conditions. Let me paint you a picture, a gentle metaphor that might help make this more intuitive. Imagine you're watching a river, following it upstream as we did before, but this time you're paying attention not to the water, but to the waves on its surface. These waves have a clear direction, moving downstream, and you could think of them as representing the flow of time. As you go further upstream, the waves get smaller and smaller, until eventually you reach a place where the water is perfectly still, perfectly smooth. There are no waves at all. Does this mean the river ends here? No, the river continues, but in a different state, a state without waves. The waves, like time, are an emergent property that only appears under certain conditions. Similarly, time as we experience it might be an emergent property of the universe that only appears under certain conditions, when the universe has cooled enough, expanded enough, become complex enough for time to make sense as a concept. Before those conditions were met, in the ultra-hot, ultra-dense state near the Big Bang, there might have been existence without time, or with a kind of proto-time that we don't yet understand. This wouldn't be a time before time, which is a contradiction, but rather a timeless state from which time emerged, like waves emerging on previously still water. Some theories go even further, suggesting that time might be fundamentally discrete rather than continuous, made up of indivisible units like the frames of a movie, rather than flowing smoothly like we perceive it. In loop quantum gravity, for instance, space-time itself is quantized at the Planck scale, made up of tiny loops and nodes that form a kind of space-time foam. At this scale, the notion of smooth continuous time breaks down completely. There is no between one Planck time and the next. They are adjacent in the most fundamental sense possible. If this is true, then asking about the first moment of time might be like asking about the first integer. You can always imagine a previous one, extending backward forever, or you might have a different structure entirely where the question doesn't even make sense. But perhaps the most mind-bending possibility comes from quantum mechanics itself. In quantum mechanics, particles don't have definite properties until they're measured. An electron doesn't have a definite position. It exists in a superposition of all possible positions until you observe it. Similarly, the universe itself might not have a definite history. Instead, it might exist in a superposition of all possible histories, including ones with different beginnings, or no beginning at all. This is the approach taken by the Wheeler-DeWitt equation, sometimes called the wave function of the universe, which attempts to apply quantum mechanics to the cosmos as a whole. In this quantum view, asking whether the universe had a beginning is like asking whether Schrödinger's cat is alive or dead before you open the box. The question assumes a definiteness that doesn't exist. The universe might be in a superposition of having begun and having always existed, and only our observations, our existence as conscious beings within the universe, causes this superposition to collapse into the particular history we observe. But other observers, in other parts of the multiverse perhaps, might observe different histories, different beginnings or lack thereof, all equally real from their perspectives. This brings us to a profound realization that I want you to sit with for a moment, to really let it sink into your consciousness like rain into thirsty soil. Time, this thing that seems so fundamental to our existence, that structures every aspect of our experience, might not be fundamental at all. It might be emergent, approximate, observer-dependent. The flow from past to future that seems so obvious, so undeniable, might be an illusion created by our particular perspective, our particular way of being in the universe. And if time itself is not fundamental, then questions about the beginning of time might be meaningless, like asking about the colour of Wednesday or the weight of mathematics. Now, I know this might feel disorienting, even disturbing. If time isn't real in the way we thought, if past and future all exist simultaneously in some block universe, then what about free will? What about the choices we make, the plans we form, the hopes we nurture for tomorrow? Does anything we do matter if the future already exists somewhere in the block? These are deep questions, and I won't pretend to have definitive answers. But I can offer you this perspective. Even if the future exists in some tenseless eternal way in the block universe, it doesn't exist independently of the present. The future is what it is because of what the present is, including your choices, your actions, your thoughts right now. You're not separate from the block universe, looking at it from outside. You're part of it, and your existence, your consciousness, your decisions are threads in the fabric of space-time itself. Think of it like a novel. From one perspective, all the pages of the novel exist simultaneously. The ending is already written, already there in the last pages even when you're reading the first chapter. But from another perspective, the perspective of the characters in the novel, the story unfolds moment by moment, choice by choice. Both perspectives are valid, and neither negates the other. The existence of the last page doesn't make the first page less important, or the middle chapters less meaningful. Every part of the story matters because it's all part of the same unified narrative, and here's something even more wonderful to consider. If time is emergent rather than fundamental, if it arises from something deeper and more basic, then there might be many different ways for time to emerge, many different kinds of time, each with its own character and properties. Our universe might have one kind of time, smooth and continuous and flowing in one direction. Other universes might have different kinds of time, discrete or circular or branching or multidimensional. Some universes might have no time at all, existing in an eternal, timeless state that we can barely imagine. In fact, some physicists have proposed that our own universe might have multiple time dimensions, not just the one we experience. These extra time dimensions might be compact, curled up so small that we don't notice them, or they might be accessible only at extremely high energies, like those present in the early universe. If there are multiple time dimensions, then the question of the universe's beginning becomes even more complex. Which time dimension are we talking about? Do they all have beginnings? Do some have beginnings while others are eternal? The possibilities multiply, and with them the mystery deepens. Let's bring this back to something more concrete, more connected to your immediate experience. Right now, as you listen to or read these words, you're experiencing a moment of time. This moment feels special, unique, different from all the moments that came before and all that will come after. And in a very real sense, it is special. It's the moment where your consciousness is located, where your awareness is focused, where you're actually alive and experiencing. But if the block universe picture is correct, this moment is also eternal. It doesn't pass away, it remains forever as a fixed point in the four-dimensional structure of space-time. The you of this moment always exists, always is experiencing this exact experience, even as the you of other moments experiences other things. This might sound abstract, but it has profound implications for how we think about mortality, memory, and meaning. Every moment of your life, from your first breath to your last, exists eternally in space-time. Your childhood self is not gone. They exist at their coordinates in the block, forever young, forever experiencing those first discoveries of the world. Your future self is not yet to be. They already exist at their coordinates, experiencing whatever they will experience. And the you of right now, this exact moment, will always exist right here, right now, a permanent feature of the cosmic tapestry. But let's return to our main question. What does it mean for the universe to have no beginning in time? We've seen that time itself might not be fundamental, that it might emerge from something deeper. We've seen that even if time is fundamental, it might extend infinitely into the past, or curve back on itself, or exist in a superposition of different states. But there's another possibility we should consider, one that brings together many of the ideas we've been exploring. Perhaps the universe has no beginning, not because it extends infinitely into the past, but because the very concept of beginning doesn't apply at the most fundamental level of reality. Consider the equations that physicists use to describe the universe. Einstein's field equations of general relativity, the Schrödinger equation of quantum mechanics, the standard model equations of particle physics. These mathematical structures don't have beginnings or endings. They simply are. They describe relationships, patterns, structures. that exist timelessly in the realm of mathematical possibility. When we say the universe obeys these equations, we're saying that physical reality instantiates or embodies these mathematical structures. But the structures themselves don't begin or end. They exist eternally in the Platonic realm of mathematics. Some physicists and philosophers have taken this idea to its logical conclusion, proposing that the universe literally is a mathematical structure. This is called the mathematical universe hypothesis, and while it might sound bizarre, it offers a potential resolution to the question of the universe's beginning. Mathematical structures don't begin, they simply exist. The number pi doesn't have a beginning. It's an eternal truth about the relationship between circumference and diameter. Similarly, if the universe is a mathematical structure, it doesn't need a beginning. It exists eternally as a solution to some set of equations, a pattern in the vast landscape of mathematical possibility. From this perspective, what we call the Big Bang is not the beginning of existence, but rather a special point in the mathematical structure, like the origin in a coordinate system. It's a useful reference point, a place from which we can measure distances and times, but it's not more fundamental than any other point. The universe extends through the Big Bang and beyond, into regions we call before the Big Bang, though these regions might have properties very different from the universe we observe. This mathematical view of reality might seem cold and abstract, but I find it deeply beautiful and even comforting. It means that existence is not arbitrary or accidental, but necessary as mathematics itself. It means that the universe is not just described by elegant equations, but is those equations made manifest. And it means that we, as conscious beings capable of discovering and understanding these equations, are the universe coming to know itself in its most fundamental form. As we've journeyed through these ideas about time, you might have noticed your usual sense of temporal flow beginning to soften, to become less rigid. This is exactly as it should be. The tight grip we usually maintain on past and future, the anxiety about time passing, the fear that we're running out of time, all of this can relax when we realize that time might not be what we thought it was. If all moments exist eternally in the block universe, then nothing is ever truly lost. If time is emergent rather than fundamental, then our deeper nature might be timeless. If the universe is a mathematical structure, then we are eternal patterns in an infinite tapestry of possibility. And yet, even as we entertain these vast abstract ideas, we remain grounded in the immediate reality of experience. You're still here, still now, still breathing and thinking and feeling. The mystery of time doesn't negate the reality of this moment. If anything, it makes it more precious, more worth attending to. Because whether time is fundamental or emergent, whether it has a beginning or extends eternally, whether it flows or is static, this moment, your moment, is real and unique, and will never come again, even as it never truly goes away. We could explore the nature of time forever, and in a sense, perhaps we are, perhaps we always have been, perhaps we always will be. But our journey tonight has other territories to explore, other mysteries to contemplate. We've seen how the universe might have no beginning because time itself might have no beginning, or because time might not be fundamental, or because beginnings might be meaningless in a mathematical universe. Now we need to look at the evidence, the actual observations and measurements that scientists have made that might tell us something about what, if anything, came before the Big Bang. Because while philosophers and theorists can speculate endlessly about the nature of time and existence, ultimately our understanding of the universe must be grounded in observation, in the actual light that reaches our telescopes, the actual particles that hit our detectors, the actual patterns we see written across the sky. And remarkably, beautifully, mysteriously, these observations might actually contain clues about the universe's deep past, about times before what we usually call the beginning, about the echoes of, well, that's what we're about to explore. The transition from thinking about time in abstract terms to looking for actual evidence of what came before the Big Bang is like moving from studying maps to actually travelling through the territory. The maps, our theories and equations, suggest possibilities, but the territory, the actual universe, tells us which possibilities are realised. And one of the most powerful ways we have of exploring the universe's deep history is by studying something called the cosmic microwave background, or CMB, a faint glow of radiation that fills all of space and carries within it information from when the universe was only 380,000 years old. But to understand what the CMB might tell us about the universe's beginning or lack thereof, we need to understand what it is, where it comes from, and why it's so special. And that's exactly where we're heading next, into the realm of ancient light and cosmic echoes, into a story written not in words but in wavelengths, a story that might, just might, extend beyond the Big Bang into territories we're only beginning to imagine. The universe, in its infinite creativity, has left us clues everywhere, written in light and gravity, in the distribution of galaxies and the abundance of elements, in the whispers of radiation that fill every cubic centimetre of space. And perhaps the most profound of these clues, the most ancient and revealing, is something we call the cosmic microwave background, the CMB, a faint glow that surrounds us always, everywhere, a kind of cosmic baby picture from when the universe was young and hot and simple. Tonight, as we continue our journey into the question of beginnings and endings, we turn our attention to this ancient light and to the tantalizing possibility that it might contain echoes from before the Big Bang, fingerprints of a deeper past that extends beyond what we usually think of as the beginning of everything. Imagine, if you will, that you're standing in a vast cathedral at night, a space so large that you can't see the walls or ceiling, only darkness stretching in every direction. You speak a word, just one word, and it echoes back to you from the unseen architecture, bounced and reflected and transformed by the shape of the space around you. From that echo alone, if you knew how to listen, you could learn about the cathedral's size and shape, about the materials of its construction, about obstacles and openings you cannot see. The cosmic microwave background is like that echo, except instead of sound bouncing off walls, it's light that has been travelling through the universe for nearly 14 billion years, carrying information about the cosmos when it was young, and perhaps, if we're very careful and very clever, information about what came even before. Let me tell you the story of how we discovered this cosmic echo, because it's a story that beautifully illustrates how the universe reveals its secrets to those who are patient enough to listen. In the 1960s, two radio astronomers named Arno Penzias and Robert Wilson were working with a large horn antenna in New Jersey, trying to measure radio waves from our galaxy. But they kept detecting an annoying background noise, a faint hiss that seemed to come from every direction equally. They tried everything to eliminate it, even cleaning out pigeon droppings from the antenna in case those were causing interference. But the noise persisted, unchanging, universal, mysterious. What they had discovered, though they didn't realize it at first, was the afterglow of the Big Bang itself, radiation that has been traveling through space since the universe became transparent to light about 380,000 years after the Big Bang. Before that time, the universe was so hot and dense that it was opaque, like the interior of a star. Light couldn't travel far before being absorbed and re-emitted by the plasma that filled all of space. But as the universe expanded and cooled, electrons and protons combined to form neutral hydrogen atoms, and suddenly, dramatically, the universe became transparent. The light that was present at that moment has been travelling ever since, stretched by the expansion of space from visible light into microwave radiation, forming the CMB we observe today. This discovery was revolutionary because it provided direct observational evidence for the Big Bang model of cosmology. The CMB is almost perfectly uniform in all directions, with a temperature of about 2.7 degrees above absolute zero, exactly what you'd expect if the universe had expanded from a hot, dense state. But the key word there is almost. The CMB is not perfectly uniform, it has tiny variations, differences in temperature of just a few parts in 100,000. These tiny variations are incredibly important, because they represent the seeds from which all the structure in the universe grew. The slight overdensities that would eventually collapse under gravity to form galaxies and clusters of galaxies. Scientists have observed that these temperature variations follow particular patterns, what cosmologists call the power spectrum of the CMB. It's like the universe's fingerprint, unique and revealing. By measuring this power spectrum precisely, cosmologists can determine fundamental properties of the universe, its age, its composition, its geometry, its expansion history. The CMB has become our most powerful tool for understanding the cosmos on the larger scales, a window into the universe's infancy that tells us not just what the baby looked like, but hints at the circumstances of its conception. But here's where things get really interesting for our exploration tonight. While the standard interpretation of the CMB is that it shows us the universe as it was 380,000 years after the Big Bang, some cosmologists have begun to wonder whether it might also contain information from even earlier times, perhaps even from before the Big Bang itself. You see, if the Big Bang was not the absolute beginning, but rather a transition from some previous state, then that previous state might have left its mark on the CMB, subtle patterns or anomalies that don't fit with the standard picture of cosmic evolution. And indeed, as our measurements of the CMB have become more precise, we have found some puzzling features that don't quite match what we expected. There's something called the cold spot, a region of the CMB that's significantly colder than it should be according to standard models. There are alignments of certain features that seem to define a special direction in space, sometimes called the axis of evil, though it's not evil at all, just unexpected. There are hints of patterns that might repeat across the sky in ways that standard cosmology doesn't predict. Each of these anomalies might have a conventional explanation, some detail of cosmic evolution we haven't fully understood yet. But they might also be telling us something more profound, that our universe carries within it memories of times before what we call the beginning. One of the most intriguing proposals is that these anomalies might be evidence of collisions between our universe and other universes in a vast multiverse. Imagine bubble universes forming in an eternally inflating space-time, occasionally bumping into each other like soap bubbles in a cosmic bath. These collisions would leave characteristic patterns in the CMB, circular features with specific temperature profiles. Some cosmologists claim to have found hints of such collision signatures, though the evidence is controversial and hotly debated. If confirmed, it would mean that our universe is not alone, that it exists in a larger context, and that the Big Bang might have been just our local bubble's beginning, not the beginning of everything. Another possibility is that the CMB contains echoes from a previous cycle of cosmic evolution. In cyclic models of cosmology, the universe goes through repeated phases of expansion and contraction, with each Big Bang followed eventually by a big crunch, which then bounces into another Big Bang. If this is correct, then information from the previous cycle might survive through the bounce, encoded in the CMB of the next cycle. Some theorists have proposed that concentric circles of uniform temperature in the CMB could be such echoes, ripples from massive events in the previous cosmic cycle that have propagated through the bounce into our own epoch. The search for these pre-Big Bang echoes has led to increasingly sophisticated observations of the CMB. Satellites like COBE, WMAP, and most recently Planck have mapped the CMB with extraordinary precision, measuring temperature variations down to millionths of a degree. Ground-based experiments in Antarctica and the Atacama Desert, where the air is thin and dry and interference is minimal, push even further, looking for subtle polarization patterns that might reveal gravitational waves from the earliest moments of cosmic history, or perhaps from before those moments entirely. Let me paint you a picture of what these observations actually involve, because there's something deeply moving about the effort humanity puts into understanding our cosmic origins. Picture a satellite floating in the darkness beyond Earth's orbit, slowly spinning, its instruments cooled to near absolute zero to detect the faintest whispers of microwave radiation. For years it scans the sky, building up a map pixel by pixel, frequency by frequency. The data flows back to Earth, where teams of scientists carefully remove contamination from our galaxy, from distant galaxies, from the instrument itself, like archaeologists carefully brushing away dirt to reveal an ancient artifact. What emerges is a map of the universe as it was when it was only 0.03% of its current age, a baby picture of cosmos itself. Or imagine the South Pole, where the air is so cold and dry that it's almost like being in space. Here, surrounded by endless ice, stands a telescope designed specifically to study the CMB. Through the long Antarctic winter, when the sun doesn't rise for 6 months, this telescope stares at the same patch of sky, accumulating data with patience that would test a saint. The scientists who operate it live in isolation that most of us can barely imagine, all in service of answering questions about the universe's deepest past. There's something beautiful, almost spiritual about this dedication to understanding, this willingness to go to the ends of the earth to listen to echoes from before the beginning of time. The data from these observations has revealed the CMB in stunning detail, and with it, a picture of the early universe that's both beautifully simple and mysteriously complex. The simplicity comes from the fact that the CMB is remarkably uniform, suggesting that the early universe was in a state of near-perfect thermal equilibrium. This is actually a puzzle in itself called the horizon problem. Regions of the universe that we see in opposite directions in the CMB have the same temperature to extraordinary precision, even though in the standard Big Bang model they were never in causal contact, never had time to exchange energy and come to equilibrium. It's like finding that two people who have never met or communicated somehow have exactly the same body temperature to 10 decimal places. The solution to this puzzle, proposed in the 1980s, is cosmic inflation, a period of exponentially rapid expansion in the universe's first fraction of a second. During inflation, a tiny region of space, small enough that it had time to come to equilibrium, was stretched to enormous size, becoming the entire observable universe we see today. This would explain the CMB's uniformity, and inflation has become a cornerstone of modern cosmology. But inflation raises its own questions. What caused it? What came before it? Did it happen just once, or is it happening still, creating new universes even as we speak? Some versions of inflation naturally lead to eternal inflation, where inflation never completely ends but continues forever in some regions of space-time, constantly spawning new bubble universes like ours. In this picture, our Big Bang was just the end of inflation in our particular bubble, and the CMB we observe is specific to our bubble. But the larger inflating space-time has no beginning. It is eternal, always has been inflating, always will be inflating, a cosmic perpetual motion machine that needs no external cause or trigger. The CMB then becomes not a relic of the beginning of everything, but a relic of the beginning of our local patch of something much larger and older. But the complexity in the CMB comes from those tiny variations I mentioned, the seeds of cosmic structure. These variations are not random. They follow specific statistical patterns that encode information about the physics of the early universe. By analysing these patterns, cosmologists can test different models of inflation, different ideas about the universe's initial conditions, different proposals for what might have come before. It's like the universe left us a coded message in the CMB, and we're slowly learning how to read it. One of the most exciting developments in CMB research is the search for primordial gravitational waves, ripples in space-time itself that would have been produced during inflation, or perhaps during some pre-Big Bang epoch. These gravitational waves would leave a distinctive swirling pattern in the polarization of the CMB, what cosmologists call B-modes. Detecting these B-modes would be like finding a fossil from before the Big Bang, direct evidence of physics from the universe's deepest past, or perhaps from before its conventional beginning. In 2014, a team using a telescope called BICEP-2 at the South Pole announced that they had detected these primordial B-modes, evidence of gravitational waves from inflation. The announcement made headlines worldwide. It seemed we'd finally pierced the veil and glimpsed what happened in the universe's first moments, perhaps even before those moments. But as other scientists examined the data, it became clear that the signal was contaminated by dust in our own galaxy. The primordial B-modes, if they exist, remain hidden, waiting for more sensitive instruments and more careful analysis to reveal them. This story of discovery and retraction, of excitement and disappointment, is typical of science at the frontier. We're pushing the limits of what's possible to observe, trying to extract signals that are almost impossibly faint from noise that's overwhelmingly strong. It's like trying to hear a whisper from across a crowded, noisy room, except the room is the entire universe, and the whisper is 14 billion years old. The fact that we can even attempt this, that we have any hope of success, is a testament to human ingenuity and persistence. As we study the CMB in ever greater detail, we're also finding features that challenge our standard models in subtle ways. The universe appears to be very slightly lopsided, with temperature variations that are slightly larger on one side of the sky than the other. There are cold spots and hot spots that are larger than expected, alignments that shouldn't exist if the universe is truly random and isotropic. Some of these anomalies might be statistical flukes, the kind of patterns that emerge by chance even in random data. But some might be telling us that our models are incomplete, that there's physics we don't understand yet, perhaps physics from before the Big Bang. One particularly intriguing idea is that the CMB might contain evidence of a previous universe in the form of Hawking points, regions where the CMB is slightly warmer due to the evaporation of supermassive black holes in a previous cosmic cycle. Roger Penrose, one of the most creative mathematical physicists of our time, has proposed that the universe goes through repeated cycles, which he calls aeons, with the infinite future of one aeon becoming the Big Bang of the next, through a process called conformal cyclic cosmology. In this picture, information can pass from one aeon to the next, and the CMB of our aeon might contain signals from the previous one. The search for these Hawking points is controversial, with different groups analysing the same CMB data and reaching different conclusions. Some claim to have found statistically significant evidence for these warm spots, while others argue that they're seeing patterns in noise, like finding shapes in clouds. This debate is healthy and necessary. Extraordinary claims require extraordinary evidence, and the claim that we can see through the Big Bang to a previous universe is about as extraordinary as they come. But even if we haven't yet found definitive evidence of a pre-Big Bang universe in the CMB, the search itself is transforming our understanding of cosmology. We're developing new statistical techniques, new ways of analysing data, new theoretical frameworks for thinking about the universe's beginning or lack thereof. We're learning that the CMB is even richer in information than we thought, containing not just the universe's baby picture, but perhaps fragments of its ultrasound, hints of development before birth. And there's so much more to explore. Future missions will map the CMB with even greater precision, looking for the subtle signatures of primordial gravitational waves, searching for evidence of cosmic collisions, testing models of inflation and alternatives to inflation. Ground-based telescopes will push to smaller scales, where the CMB has been processed by billions of years of cosmic evolution, looking for clues about dark matter, dark energy, and the nature of gravity itself. Each new observation brings new puzzles, new questions, new possibilities. The CMB also connects to other cosmic messengers that might carry information from the universe's deep past. Gravitational wave detectors like LIGO and Virgo, which have already revolutionized our ability to observe the universe, might eventually detect a background of gravitational waves from the early universe or from before the Big Bang. Neutrino telescopes might capture relic neutrinos from the first second after the Big Bang, or perhaps from even earlier times. Each of these messengers offers a different window into the past, a different way of testing our ideas about beginnings and endings. As I describe these observations and possibilities, I want you to appreciate not just the science, but the poetry of it all. We are collections of atoms that have organised themselves in such a way that they can look back across billions of years and contemplate their own origins. We build instruments of extraordinary sensitivity to detect signals of almost impossible faintness, all to answer questions that have no practical application except to satisfy our deep need to understand. There's something magnificent about this, something that speaks to the best of what we are as a species. The cosmic microwave background, this faint glow that fills all of space, is like the universe's memory, encoding information about its past in patterns of light and darkness, hot and cold. And just as our own memories shape who we are, the universe's memory shapes what it is. The slight variations in the CMB that we observe today determined where galaxies would form, where stars would ignite, where planets would coalesce, and ultimately where life would emerge. We exist because of those tiny fluctuations in temperature 13.8 billion years ago, or perhaps, if our speculations are correct, because of events even earlier, before what we call the beginning. Think about this for a moment. Every atom in your body except for hydrogen was forged in the heart of a star. But the star could only form because of a slight overdensity in the matter distribution of the early universe. That overdensity is visible in the CMB as a slightly warmer spot, a fluctuation of a few millionths of a degree. So in a very real sense, you can see your origins in the CMB. Somewhere in that map of the ancient sky is the seed that would grow into the galaxy, that would form the star that would create the atoms that would become you. You are not separate from this cosmic history. You are its continuation, its current chapter, its way of looking back and understanding itself. But if the universe has no beginning, if it extends infinitely into the past or cycles through repeated aeons, then this story becomes even richer. You're not just the product of 13.8 billion years of cosmic evolution. You're the product of an eternal process that has no starting point. The atoms in your body might have been through countless cycles, part of countless stars in countless universes, each one leaving its subtle mark, its quantum memory, that contributes to what you are today. You're not just star stuff, you might be eternal stuff, recycled and renewed through cosmic cycles beyond counting. As we continue to study the CMB and search for echoes from before the Big Bang, we're also confronting deep philosophical questions about the nature of science and knowledge. How can we test theories about what happened before the Big Bang if we can't observe it directly? How do we distinguish between different models that make similar predictions about what we can observe? How do we know when we're seeing real patterns versus imposing our expectations on noise? These are not easy questions, and they remind us that cosmology, despite all its mathematical sophistication and observational precision, remains partly philosophy, partly poetry, an attempt to tell a story about everything that necessarily goes beyond what we can directly verify. But this doesn't diminish the enterprise. If anything, it makes it more remarkable. We're using the tools of science, observation and mathematics, logic and reasoning, to probe questions that once belonged purely to mythology and religion. We're finding that the universe is far stranger than our ancestors imagined, far more vast in both space and time, possibly eternal and infinite, possibly one of many, possibly cycling through deaths and rebirths like a cosmic phoenix. And we're finding hints, tantalizing if not yet conclusive, that we might actually be able to detect echoes from before the Big Bang, signals from the universe's deep past or from its previous incarnations. The cosmic microwave background, this ancient light that surrounds us always, is like a message in a bottle that has been floating through space for billions of years. We've only recently learned how to open the bottle and begin reading the message. What we've read so far has revolutionized our understanding of the cosmos, confirming the Big Bang model, revealing the universe's composition and geometry, showing us the seeds of cosmic structure. But there might be more to the message, hidden layers of meaning that we're only beginning to decipher. Perhaps it contains proof that the universe had no beginning, that time extends infinitely into the past. Perhaps it shows evidence of other universes, other cycles, other realities beyond our own. Perhaps it will reveal something we haven't even imagined yet, something that will once again force us to completely reconceptualize our place in the cosmic order. As we prepare to move forward in our exploration, to consider not just the universe's possible lack of beginning, but its multiple possible endings, I want you to carry with you this image of the CMB as the universe's memory, ancient light that connects us to the deepest past and perhaps to times before time. Every photon of this cosmic background radiation has been traveling for nearly 14 billion years to reach us, carrying information about the universe when it was young and simple and full of potential. Some of these photons are hitting your body right now, passing through you as they continue their eternal journey through space. You're literally immersed in the afterglow of the Big Bang, swimming in ancient light, surrounded always by echoes of the cosmic past. And perhaps, if we're very clever and very lucky, some of these photons carry information from even deeper in the past, from before the Big Bang, from previous cycles or parallel universes or states of existence we can barely imagine. We're just beginning to learn how to read these most ancient of signals, how to decode these most subtle of messages. What we'll find as we improve our techniques and our instruments, as we look deeper and more carefully, remains to be seen. But the search itself, the quest to understand our ultimate origins, to trace the universe back to its beginning, or to discover that it had no beginning, is one of the most profound undertakings of human civilization. We've now explored three deep aspects of our central question, the possibility that the universe had no beginning, the nature of time itself and whether it needs a first moment, and the echoes in the cosmic microwave background that might tell us about times before the Big Bang. Each of these explorations has opened up new mysteries, new questions, new possibilities. We've seen that the universe might be eternal, that time might be emergent, that our cosmic history might extend beyond what we thought was the beginning of everything. But we've only been looking backward, into the past, toward beginnings or the lack thereof. Now it's time to turn our gaze forward, toward the future, toward endings. Because if the universe might have no beginning, it might also have no single ending. Instead, it might face multiple endings, different conclusions playing out in different regions of space and time, a symphony of finales rather than a single final note. And that's where our journey takes us next, into the far future, into the realm of cosmic endings that are as mysterious and multiple as the beginnings we've been contemplating. What if, just maybe, the universe does not have one single final curtain, but many soft closings scattered across infinity like the last notes of different instruments in an orchestra that never quite stops playing, each section finding its own moment of silence, its own way of resting. We've spent our time together so far contemplating the possibility that the universe had no beginning, that time itself might stretch eternally into the past or emerge from something deeper and more fundamental. Now, as we continue our journey through these cosmic mysteries, we turn our attention forward, toward the future, toward endings, but not just one ending, rather a multitude of possible conclusions, each one unique, each one final in its own way, yet none of them necessarily the end of everything. This idea of multiple endings might seem even stranger than the idea of no beginning. After all, we're used to thinking of the future as something singular, something that will happen, not something that might happen in many different ways simultaneously. But modern cosmology, with its vast scales and quantum uncertainties, suggests that the universe's future might be far more complex, far more varied, far more creative than we ever imagined. Different regions of space might evolve toward different fates, some cooling toward absolute zero, others perhaps collapsing or transforming in ways we're only beginning to understand. The universe might not die all at once, in one grand finale, but might instead fade away in countless small endings, each one a quiet goodbye in the vast cosmic night. Let me paint you a picture that might help make this more intuitive. Imagine you're standing on a hill at sunset, watching a vast forest spread out before you as far as you can see. As the sun sinks lower, different parts of the forest fall into shadow at different times. A valley here grows, dark while a distant hilltop still glows with golden light. One grove of trees loses its illumination while another, oriented differently, catches the last rays. The forest doesn't experience a single moment of sunset. Instead, sunset happens gradually, unevenly, uniquely across its vast expanse. Each tree, each clearing, each stream has its own experience of the day's ending, its own moment of transition from light to darkness. The universe might be like that forest, but on a scale so vast that we can barely comprehend it. Different regions, separated by distances so enormous that light itself will never have time to travel between them, might experience their own unique endings, their own transitions from the current epoch of stars and galaxies to whatever comes after. These endings might happen at different times or in regions so causally disconnected that the very concept of at the same time becomes meaningless. Each region might write its own final chapter, tell its own concluding story, find its own way of settling into whatever comes after the age of light and matter and complexity that we currently inhabit. To understand how this could be possible, we need to talk about one of the most surprising discoveries in modern cosmology: the acceleration of cosmic expansion. You see, for most of the 20th century, cosmologists assumed that the expansion of the universe, which began with the Big Bang, must be slowing down. After all, gravity is attractive, and all the matter in the universe should be pulling on all the other matter, gradually slowing the expansion like friction slows a rolling ball. The question was whether there was enough matter to eventually stop the expansion entirely and reverse it, leading to a big crunch, or whether the universe would expand forever, just more and more slowly. But in 1998, two teams of astronomers studying distant supernovae made a shocking discovery. The expansion of the universe is not slowing down, it's speeding up. Something is pushing space apart faster and faster, overwhelming the attractive force of gravity on cosmic scales. We call this something dark energy, though that's really just a label for our ignorance. We don't know what dark energy is, only that it makes up about 68% of the energy density of the universe, and that it's causing space to expand at an accelerating rate. This discovery changed everything about how we think about the universe's future. If the acceleration continues, and we have no reason to think it won't, then the universe will expand forever, growing larger and colder and emptier. Galaxies that aren't already gravitationally bound to each other will drift apart, carried away by the expansion of space itself. Eventually, every galaxy will be alone, an island universe in an infinite dark sea, unable to see or communicate with any other galaxy. The observable universe will shrink even as the total universe grows, a paradox that captures something essential about the nature of cosmic endings. But here's where the idea of multiple endings becomes really interesting. Because the universe is so vast, possibly infinite, and because different regions can evolve independently once they're no longer in causal contact, we might see a variety of different endings playing out across the cosmos. Let me describe some of these possibilities, not to alarm or depress you, but to inspire wonder at the creativity and diversity of cosmic evolution. In regions where matter is relatively dense, where galaxies cluster together in vast cosmic webs, gravity might win local battles against dark energy. These regions might continue to evolve for trillions of years, with galaxies merging, black holes growing, stars forming from recycled gas until all the fuel is exhausted. The ending here might be what physicists call the Big Freeze or heat death, a state where all the stars have died, all the black holes have evaporated through Hawking radiation, and the universe reaches maximum entropy, a state of perfect uniformity where nothing more can happen. But in other regions, where matter is more sparse, the acceleration might dominate earlier and more completely. These regions might experience what's called the Big Rip, where dark energy doesn't just push galaxies apart but eventually overcomes all forces, tearing apart galaxies themselves, then solar systems, then planets, then atoms, until space itself is ripped into some kind of quantum foam. This ending would be more dramatic but also quicker, happening in finite time rather than the infinite approach to heat death. And there might be still other possibilities, other endings we haven't even imagined yet. Perhaps in some regions of the universe, dark energy isn't constant but changes over time, leading to cycles of acceleration and deceleration, expansion and contraction. Perhaps quantum effects become important on cosmic scales in the far future, leading to phase transitions where the vacuum itself changes state, creating bubbles of new physics that expand at the speed of light, rewriting the laws of nature as they go. Perhaps consciousness itself, whether human or artificial or something we can't imagine, will play a role in determining how different regions of the universe evolve toward their endings. The key insight is that the universe is not monolithic, not uniform on the larger scales despite appearances. Yes, the cosmic microwave background is remarkably smooth, and yes, the universe looks pretty much the same in all directions when we average over large enough scales. But there are variations, fluctuations, differences that become magnified over cosmic time. A region that's slightly denser than the average evolves differently from one that's slightly less dense. A region with a massive black hole at its center has a different future from one without. These differences, tiny at first, compound over billions and trillions of years, leading to genuinely different outcomes. Think about it this way, and let this image settle gently into your consciousness like a leaf settling onto the surface of a still pond. The universe is like a vast garden where every flower blooms and fades on its own schedule. Some flowers open with the dawn and close at dusk. Others bloom at night, opening their petals to the moon and stars. Some live for just a day, others for seasons, still others for years. The garden as a whole doesn't have a single moment of blooming or a single moment of fading. Instead, it's always in a state of mixed flowering and decay, always changing, always finding new patterns of growth and decline. Our own region of the universe, the local group of galaxies that includes the Milky Way and Andromeda, and a few dozen smaller galaxies, will have its own unique ending, different from the endings of other regions. In about 4 billion years, the Milky Way and Andromeda will collide and merge, creating a giant elliptical galaxy that some astronomers have already named Milkomeda. This collision won't be violent in the way we usually think of collisions. The stars are so far apart that they'll mostly just pass by each other. But the gravitational disturbances will trigger new waves of star formation, a last burst of cosmic creativity before the long, slow fade into darkness. After the merger, Milkomeda will be alone, the other galaxies of the local group either absorbed or flung away. The more distant galaxies will have receded beyond the cosmic horizon, carried away by the accelerating expansion of space. To future observers in Milkomeda, if any exist, the universe will appear to contain just one galaxy, surrounded by absolute darkness. They'll have no way of knowing about the billions of other galaxies that once filled the observable universe. No evidence of the cosmic web, no hint of the universe's true vastness. Their universe will have shrunk to a single island of stars in an infinite void. But even this isn't the end of the story for our region. The stars in Milky Way will continue to age and die, with smaller, redder stars lasting longer than large blue ones. The longest-lived stars, the red dwarfs, can shine for trillions of years, far longer than the current age of the universe. But even they will eventually exhaust their fuel and fade to black, becoming cold, dark objects called black dwarfs. By this time, so far in the future that it makes the current age of the universe seem like an eye blink, Milky Way will be a graveyard of dead stars, orbiting a supermassive black hole that itself is slowly evaporating through Hawking radiation. And yet, even in this seemingly dead galaxy, interesting things might still happen. Occasionally, two black dwarfs might collide, creating a brief flash of light in the darkness. Quantum tunneling might cause some black dwarfs to collapse into black holes, which would then evaporate. On even longer timescales so vast that we need scientific notation to write them down, protons themselves might decay, causing all ordinary matter to dissolve into radiation and elementary particles. The very atoms that make up everything we know might be unstable on cosmic timescales, though we haven't yet observed proton decay despite searching for it. Different regions of the universe might reach these various stages at different times, or might skip some stages entirely depending on their particular conditions. A region dominated by a supermassive black hole might evolve differently from one without. A region where galaxies merged early might have a different timeline from one where galaxies remained separate longer. A region where dark energy is slightly stronger or weaker, if such variations exist, might experience acceleration or deceleration on different schedules. Each region writes its own story, follows its own path toward whatever ending awaits it. This multiplicity of endings becomes even more pronounced if we consider the possibility of the multiverse, which we touched on earlier. If our universe is just one bubble in an infinite foam of universes, each with potentially different physical constants and laws, then the variety of possible endings becomes truly infinite. Some universes might collapse in a big crunch after just a few billion years. Others might expand so rapidly that structures never form at all. Still others might cycle through expansions and contractions, or might reach stable configurations that last forever, or might experience endings we can't even conceive of because they're based on physics different from our own. Even within our own universe, quantum mechanics suggests that the future is not deterministic but probabilistic. Every quantum event, from the decay of a radioactive atom to the emission of a photon from a star, represents a branching point where the universe splits into multiple versions, each following a different path. This is the many worlds interpretation of quantum mechanics, and while it's controversial, it's taken seriously by many physicists. If it's correct, then the universe doesn't have a single future, but an infinite branching tree of futures, each branch representing a different sequence of quantum outcomes, each leading to its own unique ending. From this quantum perspective, asking about the universe's ending is like asking about the ending of all possible stories that could be told with a given set of characters and rules. There isn't one answer, there are countless answers, each one realized in its own branch of the quantum multiverse. Some branches might see early endings through unlikely quantum fluctuations. Others might see extended endings through equally unlikely but opposite fluctuations. Most branches might follow the statistical middle path, but even that middle path might lead to different endings in different regions due to accumulated quantum differences over cosmic time. Let me share with you a particularly beautiful way of thinking about these multiple endings that comes from thermodynamics and information theory. The second law of thermodynamics tells us that entropy, a measure of disorder or randomness, always increases in closed systems. The universe as a whole is the ultimate closed system, so its entropy must increase over time. Eventually, the universe will reach maximum entropy, a state where no more energy can be extracted to do work, where no more information processing is possible, where nothing interesting can happen. This is the heat death I mentioned earlier, but here's the fascinating part. There might be many different ways to reach maximum entropy, many different configurations that all have the same thermodynamic properties, but different detailed structures. It's like shuffling a deck of cards. There are many different arrangements that all look equally random, that all have maximum entropy from a macroscopic perspective. The universe might explore many of these maximum entropy states simultaneously in different regions, each one representing a different ending, a different way of reaching the same thermodynamic destination. And who knows? Perhaps what looks like maximum entropy from one perspective might hide interesting structures from another perspective. Perhaps there are ways of processing information, forms of computation or consciousness, that can exist even in apparently dead universes. Perhaps the endings we envision are not really endings, but transitions to new forms of existence that we can't currently imagine. The history of science is full of surprises, of phenomena that seemed impossible until they were discovered, of limits that seemed absolute until they were transcended. As we contemplate these multiple endings, it's natural to feel a mix of emotions. There's something melancholic about imagining the universe's various deaths, the fading of light, the cooling of matter, the dissolution of structure. But there's also something beautiful about the diversity of these endings, the creativity of cosmic evolution, the fact that the universe doesn't just stop but transforms, explores, discovers new states of being, even in its decline. And remember, these endings are so far in the future that they might as well be infinite from our perspective. The universe has trillions of years of interesting evolution ahead of it, countless generations of stars still to be born, possibly countless civilizations still to arise and flourish. Moreover, the existence of multiple endings means that somewhere in the vast cosmos, almost anything that's physically possible might happen. Regions where intelligence survives and even thrives in the far future, finding ways to extract energy from black holes or dark energy itself. Regions where new universes are born from the ashes of the old, through quantum fluctuations or technological interventions or processes we haven't discovered yet. Regions where the laws of physics themselves evolve, where consciousness plays a fundamental role, where endings become beginnings in ways we can barely imagine. This is the deep beauty of a universe with multiple endings. It's not a single story with a predetermined conclusion, but an infinite library of stories, each with its own narrative arc, its own dramatic structure, its own meaning. We happen to find ourselves in one particular story, in one particular region of the cosmos, heading toward one particular ending. But that doesn't make our story less meaningful. If anything, it makes it more precious, more unique, more worth experiencing and understanding and celebrating. Think about your own life in this context. You are part of a particular thread in the cosmic tapestry, a thread that will follow its own unique path toward its own unique ending. The atoms in your body will eventually be dispersed, perhaps incorporated into new stars and planets, perhaps drifting in intergalactic space, perhaps falling into black holes. But the pattern that is you, the information that defines your consciousness, the impact you have on the world around you, these things become part of the universe's story, part of how this particular region of space-time evolves toward its particular ending. In a universe with multiple endings, every choice matters because it helps determine which ending becomes real in your region of space-time. The butterfly effect, where small changes can have large consequences, operates on cosmic scales. A single photon emitted by a star might trigger a cascade of events that determines whether two galaxies collide or miss each other. A single quantum measurement might determine which branch of the multiverse you find yourself in. A single decision by a conscious being might influence the development of technology that could ultimately affect how a region of the universe evolves over cosmic time. This is not to burden you with cosmic responsibility, but to highlight the profound interconnectedness of everything in the universe. You are not a passive observer of cosmic evolution, but an active participant. Your existence, your consciousness, your choices are part of how the universe explores its own possibilities, discovers its own potential endings, writes its own multiple stories. In a very real sense, you are one of the ways the universe is deciding how to end, at least in this local region of space-time. As we prepare to explore specific scenarios for cosmic endings in more detail, I want you to hold on to this image of the universe as a vast, diverse, creative system that doesn't march lockstep toward a single finale, but instead explores many different paths toward many different conclusions. Some of these endings might seem dark or empty from our current perspective, but each one represents a complete exploration of certain possibilities, a full working out of certain initial conditions and evolutionary paths. And remember, in a universe that might have no beginning and multiple endings, the whole concept of finality becomes fuzzy. What looks like an ending from one perspective might be a transition from another. What seems like death might be transformation. What appears to be the last page might be followed by an appendix, an epilogue, or even a whole new volume. The universe has surprised us before with its creativity and resilience, and it might well surprise us again with endings that are not really endings but doorways to something new. We've been talking about endings in rather abstract terms, as distant possibilities billions or trillions of years in the future, but now it's time to get more specific, to explore in detail one of the most likely scenarios for cosmic ending: the slow fade to darkness known as heat death. This is the ending that our current understanding of physics suggests is most probable, the ending toward which our region of the universe seems to be heading. It's an ending not of fire but of ice, not of collapse but of dispersal, not of sudden catastrophe but of gradual decline. In the great library of possible cosmic endings, there is one volume that physicists return to again and again, one story that seems most consistent with what we observe, most inevitable given the laws of thermodynamics and the accelerating expansion of space. This is the story of heat death, though the name is misleading because it's not about heat in the way we usually think of it, but about the absence of temperature differences, the evening out of all energy, the universe reaching a state of maximum entropy, where nothing more can happen, where time itself might lose meaning because there's no change to mark its passage. Tonight, let's explore this ending together, not with fear or sadness, but with the same gentle curiosity we've brought to all our cosmic wanderings, finding beauty even in the universe's quiet fade to darkness. The concept of heat death emerged in the 19th century, when physicists were first understanding the laws of thermodynamics. They realized that in any closed system, entropy, a measure of disorder or randomness, always increases. Energy flows from hot to cold, never the reverse, at least not without external input. A cup of hot coffee in a cold room will cool down, its heat spreading into the environment until coffee and room are the same temperature. The energy hasn't disappeared, it's just spread out, diluted, made uniform. And once everything is the same temperature, no more work can be done, no more interesting processes can occur. The system has reached thermodynamic equilibrium, a state of maximum entropy, a kind of death even though all the particles are still there, still moving, still existing. The universe, as far as we know, is a closed system, the ultimate closed system, with no outside to provide fresh energy or reset the entropy clock. So the same principle that cools your coffee should apply to the cosmos as a whole. Over vast spans of time, energy should spread out, temperature differences should disappear, and the universe should approach a state of thermodynamic equilibrium. Stars pour energy into space, heating their surroundings, but that energy disperses, dilutes, spreads thin. Black holes swallow matter and energy, but even they eventually evaporate through Hawking radiation, returning their mass energy to space in the form of elementary particles and photons. Given enough time, everything should even out, like ink diffusing through water until the colour is perfectly uniform. But here's what makes this cosmic heat death so different from the cooling of coffee. The timescales involved are so vast that we need to recalibrate our entire sense of duration. The universe is currently about 13.8 billion years old, and stars will continue forming for perhaps another 100 trillion years. That's already a timescale that breaks human comprehension, about 10,000 times the current age of the universe. But that's just the beginning of the story. After star formation ends, existing stars will continue shining for much longer. The smallest red dwarf stars can burn for 10 trillion years or more, slowly fusing hydrogen into helium at a rate so leisurely it makes continental drift look hasty. Let me paint you a picture of this slow stellar decline, because there's something hauntingly beautiful about it. Right now, the universe is in what we might call its stellar age, a cosmic spring or summer where stars are abundant, where galaxies shine with the light of billions of suns, where planets orbit and life potentially flourishes. But springs don't last forever, and neither does the stellar age. As the universe expands and cools, the raw material for new stars, primarily hydrogen gas, gets used up or dispersed. Star-forming regions, those stellar nurseries where gas clouds collapse under gravity to birth new suns, become rarer and smaller. The cosmic birth rate declines, like a civilization where fewer children are born each generation. The stars that already exist continue their lives, but they're not immortal. They're slowly converting their hydrogen fuel into heavier elements, and when the fuel runs out, they die. Massive stars die dramatically in supernova explosions, scattering their enriched guts across space. But these massive stars are rare and short-lived, burning out in millions rather than billions of years. The universe's future belongs to the smaller stars, the red dwarfs that make up the majority of all stars. These cosmic misers burn their fuel so slowly, so carefully, that they can shine for trillions of years. Imagine the universe trillions of years from now, when the age of star formation has ended. The galaxies are still there, but they're different, older, redder. The bright blue stars that make spiral arms visible are long gone. The yellow stars like our sun have swollen into red giants, then shrunk into white dwarfs, then cooled into black dwarfs. Only the red dwarfs remain active, glowing with a dim, ruddy light like embers in a dying fire. The universe has become a red universe, a cosmos of slow, patient stars eking out the last of their fuel, and even these red dwarfs must eventually die. When they finally exhaust their hydrogen, they don't explode, they simply fade away, cooling from red to infrared to darkness. They become black dwarfs, theoretical objects that don't yet exist because the universe isn't old enough for any star to have completed this transition. But given enough time, every star will become a black dwarf, a dense ball of degenerate matter slowly cooling toward absolute zero. By this time, we're talking about timescales that dwarf everything that's come before. The stelliferous era, the age of stars, will have lasted perhaps 100 trillion years, but the age of black dwarfs, sometimes called the degenerate era, will last much, much longer. We're entering the realm of deep time, where we need exponential notation just to write down the numbers. 1020 years, 1030 years, 1040 years, each power of 10 representing a factor of 10 increase, a time scale 10 times longer than the last. During this degenerate era, the universe will be a very different place. Galaxies will still exist, but they'll be invisible, composed of black dwarfs, neutron stars, and black holes orbiting each other in darkness. Occasionally, two of these dead stars will collide, creating a brief flash of light in the darkness, a momentary reminder of the universe's luminous past. But these collisions will be rare and getting rarer as gravitational radiation causes orbits to decay and objects to either merge or get ejected from their galaxies. The dominant objects in this era will be black holes, ranging from stellar mass black holes formed from collapsed stars to supermassive black holes that once powered quasars and now sit quietly at the centers of galaxies. These black holes might seem eternal, perfect endpoints for matter and energy. But one of Stephen Hawking's greatest discoveries was that black holes aren't perfectly black. They evaporate through a quantum process now called Hawking radiation. The temperature of this radiation is inversely proportional to the black hole's mass, so massive black holes evaporate very slowly while small ones evaporate quickly. A black hole with the mass of the Sun would take about 1067 years to evaporate completely. A supermassive black hole with 1 billion solar masses would last much longer, perhaps 100 years. These numbers are so large that they lose meaning, but the key point is that even black holes are not eternal. Given enough time, every black hole in the universe will evaporate, returning its mass energy to space in the form of elementary particles and photons. The universe will have digested and regurgitated everything, reducing all complex structures to their simplest components. This brings us to the black hole era, lasting from perhaps 1040 years to 1000 years after the Big Bang. During this unimaginably long epoch, black holes will be the only remaining active objects slowly evaporating through Hawking radiation. As they shrink, they get hotter, radiating faster, until in their final moments they explode in a burst of high-energy particles. Each black hole death is a small celebration, a brief firework in the cosmic darkness, but afterward, silence returns, deeper than before. After the last black hole is evaporated, the universe enters what's sometimes called the dark era or the photon age. All that remains are elementary particles, photons, electrons, positrons, neutrinos, drifting through empty space. Occasionally an electron and positron might find each other across the vast darkness and annihilate, producing photons. But as the universe continues to expand, these particles get more and more separated, making such encounters increasingly rare. The universe becomes a thin soup of particles growing ever thinner, ever colder, ever more dilute. In this final era, the the universe approaches heat death, the state of maximum entropy where no more work can be done, no more information can be processed, no more interesting structures can form. The temperature everywhere approaches absolute zero, though it never quite reaches it. Time might still exist in some abstract sense, but with no changes occurring, no events to mark its passage, it becomes meaningless. The universe has reached thermodynamic equilibrium, a state of perfect balance, perfect uniformity, perfect stasis. But wait, you might be thinking, doesn't this contradict what we said earlier about multiple endings? How can the universe have multiple endings if they all lead to the same heat death? The answer is subtle and beautiful. While the overall trajectory toward maximum entropy is the same, the details of how different regions reach this state can vary enormously. Some regions might reach heat death, while others still have active black holes. Some might be dominated by photons, while others have more neutrinos. The microscopic details differ, even if the macroscopic outcome is similar. Moreover, quantum mechanics introduces uncertainty even into heat death. Quantum fluctuations mean that even in thermodynamic equilibrium, random events can occur. Given enough time, and we're talking about truly cosmic timescales here, quantum fluctuations could randomly create complex structures, even entire galaxies or universes, though the probability is unimaginably small. This is related to the Boltzmann brane paradox, the disturbing possibility that random fluctuations are more likely to create isolated conscious observers than the entire ordered universe we see around us. There's also the possibility that our understanding of physics is incomplete in ways that matter for the far future. Perhaps protons don't decay, in which case black dwarfs and neutron stars could last forever. Perhaps dark energy isn't constant but changes over time, leading to different outcomes. Perhaps there are phase transitions in the quantum vacuum that could restart cosmic evolution. Perhaps consciousness or intelligence can find ways to survive and even thrive in what seems like a dead universe. Let me share with you some of the more speculative but fascinating ideas about how intelligence might persist even as the universe approaches heat death. The physicist Freeman Dyson proposed that intelligent beings could survive indefinitely by slowing down their thought processes as the universe cools, thinking slower and slower but never stopping entirely. Others have suggested that intelligence could encode itself in the quantum states of elementary particles, or in the gravitational waves that continue to propagate even in an otherwise empty universe, or in structures we haven't yet imagined. There's something poignant about imagining consciousness persisting in a cooling universe, thoughts becoming slower and slower like a clock winding down, but never quite stopping. Each thought would take longer than the current age of the universe, each memory stretched across eons, each decision contemplated for epochs. It would be a kind of existence we can barely imagine, more like hibernation or meditation than active life, but perhaps still meaningful in its own way. The approach to heat death also raises profound questions about the nature of time and existence. If the universe reaches a state where nothing changes, does time still exist? If there are no observers, no consciousness to experience duration, is there any meaningful sense in which the universe continues? Some physicists have suggested that time might actually end at heat death, not dramatically but simply by becoming undefined, like asking what's north of the North Pole. Others have proposed more radical ideas. Roger Penrose's conformal cyclic cosmology, which we mentioned earlier, suggests that the infinite future of a universe approaching heat death becomes identical to the Big Bang of a new universe. When all massive particles have decayed and only massless particles remain, the universe loses any sense of scale or time, and this state becomes indistinguishable from the hot, dense beginning of a new cosmic cycle. The heat death of one universe becomes the birth of the next, endings becoming beginnings in an eternal cycle. There's also the possibility of quantum tunneling to new vacuum states. Our universe exists in what physicists call a vacuum state, a configuration of quantum fields that determines the laws of physics. But this might not be the lowest energy state possible. We might be in a metastable state, like a ball resting in a valley on a mountainside rather than at the bottom of the mountain. Given enough time, quantum tunneling could cause the universe to transition to a lower energy state, potentially rewriting the laws of physics and restarting cosmic evolution in a completely different form. As we contemplate heat death, it's important to remember the vast timescales involved. We're talking about a future so distant that it makes the current age of the universe seem like less than a heartbeat. Stars will continue shining for trillions of years. Life and intelligence have barely begun their possible evolution. Civilizations could rise and fall millions of times over before the universe shows any signs of approaching heat death. There's so much time for interesting things to happen, for new discoveries, for solutions we haven't imagined. In fact, the universe's approach to heat death is so slow that it raises philosophical questions about whether it will ever actually arrive. In mathematics, we distinguish between approaching a limit and reaching it. A sequence can get arbitrarily close to a value without ever actually attaining it. Perhaps heat death is like that, always approached but never quite reached, always in the future no matter how much time passes. The universe might be eternally dying without ever being fully dead. This slow fade also means that different regions of the universe will experience different stages at different times. While one region has reached the black hole era, another might still have red dwarf stars shining. While one region has achieved near-perfect vacuum, another might still have particle interactions occurring. The universe's death, if we can call it that, is not simultaneous or uniform but varied and gradual, like a vast symphony where different sections fall silent at different times until eventually only silence remains. But even that silence might not be absolute. Quantum mechanics forbids perfect emptiness, perfect zero energy. Even the vacuum has fluctuations, virtual particles appearing and disappearing, fields trembling with quantum uncertainty. The universe at heat death might be like a perfectly still lake that nevertheless has tiny ripples from quantum effects, ripples that given enough time could potentially grow into something more. As I describe this slow cosmic fade, I want you to notice something important. Even in discussing the universe's death, we're really talking about transformation. Matter becomes radiation, structure becomes uniformity, complexity becomes simplicity. But nothing is truly destroyed. It's all rearranged, spread out, returned to its most fundamental form. The atoms that make up your body, the energy that powers your thoughts, will still exist in some form trillions of years from now. You're not separate from this cosmic process. You're part of it, a temporary arrangement of matter and energy that will eventually be rearranged but never annihilated. There's a deep beauty in this vision of cosmic evolution, even in its ending. The universe begins hot and dense and simple, evolves through eras of increasing complexity and structure, and then slowly returns to simplicity again, but a different kind of simplicity. Cold rather than hot, sparse rather than dense. It's like a vast breathing, an inhalation and exhalation on a cosmic scale, or like a story with a beginning, middle, and end, complete and whole in itself. And remember, this is just one possible ending, the one that seems most likely given our current understanding of physics. But our understanding has changed before, and will likely change again. A century ago, we didn't know the universe was expanding. 50 years ago, we didn't know about dark energy. Who knows what we'll discover in the next 50 or 100 or 1,000 years that might completely change our picture of the universe's future? Perhaps we'll find that dark energy weakens over time, allowing gravity to eventually halt and reverse the expansion. Perhaps we'll discover new forces or fields that become important in the far future. Perhaps intelligence will play a role we can't currently imagine. Either natural intelligence evolved to cosmic scales or artificial intelligence that transcends biological limitations. Perhaps the universe has feedback mechanisms we haven't discovered, ways of regenerating or renewing itself that prevent true heat death. The approach to heat death also connects to deep questions in philosophy and meaning. If the universe will eventually reach a state where nothing happens, does that mean nothing matters? I would argue the opposite. In a universe heading toward heat death, every moment of complexity, every instance of consciousness, every experience of beauty or love or understanding becomes even more precious because it's temporary. We are the universe's way of experiencing itself while experience is still possible. We are how the cosmos knows what it's like to be alive, to think, to feel, to wonder about our own existence and eventual non-existence. Think about a piece of music. It has a beginning and an end, and when it ends, silence returns. Does this make the music meaningless? Of course not. The meaning is in the playing, in the listening, in the experience of the music while it lasts. The universe is like that piece of music, and we are both the players and the audience, creating and experiencing the cosmic symphony while it plays. As we prepare to move on from contemplating heat death to exploring other possible endings, other ways the universe might conclude its story, I want you to carry with you this image of the slow cosmic fade. It's not a violent or sudden ending, but a gradual transformation, a patient evolution towards simplicity and quiet. There's something almost peaceful about it, like falling asleep after a long, full day, or like winter settling over a landscape, bringing rest and stillness. But just as winter is followed by spring in our earthly cycles, perhaps the universe's heat death is not truly final. Perhaps it's just another transition, another transformation in an endless sequence of cosmic changes. That's what we'll explore next. The possibility that endings lead to new beginnings, that the universe might cycle or regenerate or give birth to new universes, that death and birth might be more intimately connected on cosmic scales than we ever imagined. Consider the possibility that every ending might be a doorway, and the universe is very fond of doorways, passages that lead not to nothingness, but to new somethings, transformations that look like death from one side but birth from the other. We've explored the slow fade to heat death, that patient decline into cold and darkness that seems to await our universe trillions of years hence. But what if that's not the end of the story? What if the universe has ways of regenerating itself, of cycling through deaths and rebirths, of folding endings back into beginnings like a cosmic Ouroboros eating its own tail? Tonight, let's explore these possibilities together, these models of cosmic renewal that suggest the universe might be immortal, not through avoiding death, but through transcending it. The idea of a cyclic universe is ancient, appearing in Hindu and Buddhist cosmologies, in Stoic philosophy, in indigenous traditions around the world. But in recent decades, this ancient intuition has been given new life by modern physics, dressed in the language of mathematics and quantum mechanics, general relativity and string theory. These new cyclic models don't just assert that the universe repeats, they explain how it might happen, what mechanisms could drive cosmic cycles, what evidence we might look for in our observations of the sky. One of the most developed cyclic models is called the ekpyrotic universe, from the Greek word for conflagration, the Stoic idea that the cosmos periodically burns and renews itself. In this model, our universe is one of two three-dimensional membranes, or branes, floating in a higher dimensional space. These branes slowly approach each other, and when they collide, the kinetic energy of the collision is converted into the hot, dense matter and radiation that we identify with the Big Bang. The branes then bounce apart, and the universe expands and cools, eventually becoming empty and cold. But the branes are attracted to each other, so they eventually approach again, collide again, creating another Big Bang, another cycle of cosmic evolution. This might sound like pure speculation, but it makes specific predictions that differ from standard Big Bang cosmology. For instance, the collision of branes would produce a particular pattern of gravitational waves different from those produced by inflation. These gravitational waves would leave their mark on the cosmic microwave background, potentially observable with sufficiently sensitive instruments. The ekpyrotic model also naturally explains why our universe is so flat, so homogeneous, without requiring the rapid inflation that standard cosmology needs. The long, slow approach of the branes before collision has time to smooth out irregularities, to flatten space, to create the uniform initial conditions we observe. Another approach to cyclic cosmology comes from loop quantum gravity, one of the leading attempts to reconcile quantum mechanics with general relativity. In loop quantum gravity, space itself is quantized at the smallest scales, made of discrete loops and nodes rather than being smooth and continuous. When you apply this framework to cosmology, something remarkable happens. As you trace the universe backward toward the Big Bang, instead of reaching a singularity where density becomes infinite and physics breaks down, you reach a maximum density where quantum effects cause gravity to become repulsive rather than attractive. The universe bounces, transitioning from contraction to expansion. This big bounce scenario suggests that our Big Bang was not the beginning of everything, but the result of a previous universe collapsing. That universe might have had its own history, its own stars and galaxies, perhaps even its own life and intelligence. As it contracted, all its structure was destroyed, all its complexity erased, but not its existence. It passed through the bounce through the quantum gravitational transition and emerged as our expanding universe. And our universe, after expanding for trillions of years, might eventually contract again, bounce again, give birth to yet another universe in an endless cycle. What's beautiful about loop quantum cosmology is that it's not just philosophy or speculation, it makes concrete predictions. The bounce leaves signatures in the cosmic microwave background, subtle patterns that we might be able to detect. The quantum nature of space-time at the bounce creates particular correlations in the CMB temperature fluctuations. Some researchers claim to have found hints of these pre-Big Bang signatures, though the evidence is controversial and debated. But the fact that we can even look for such evidence, that we can potentially see through the Big Bang to a previous universe, is extraordinary. Roger Penrose's conformal cyclic cosmology, which we've mentioned before, offers yet another vision of cosmic cycles. In Penrose's model, the universe doesn't collapse and bounce, but instead undergoes a more subtle transformation. As the universe approaches heat death in the infinite future, with all massive particles decayed and only massless photons remaining, it loses any sense of scale or time. This state, Penrose argues, is mathematically identical to the hot, dense, smooth state at the Big Bang. The infinite future of one aeon becomes the Big Bang of the next, not through a physical bounce, but through a mathematical transformation called conformal rescaling. This is a mind-bending idea, that the cold, empty future of the universe could be the same as the hot, dense past of another universe, just looked at from a different perspective. It's like those optical illusions where the same image can be seen as either a vase or two faces depending on how you look at it. The universe at heat death, viewed one way, is the end of everything. Viewed another way, it's the beginning of everything. The transformation from one view to the other is what Penrose calls the crossover from one aeon to the next. In conformal cyclic cosmology, information can pass from one aeon to the next, particularly through the evaporation of supermassive black holes. As these black holes evaporate through Hawking radiation in the previous aeon, they release energy that becomes imprinted on the next aeon's cosmic microwave background as slightly warmer spots, what Penrose calls Hawking points. The search for these Hawking points in our CMB is ongoing, with different groups reaching different conclusions about whether they've been found. String theory, the ambitious attempt to unify all forces and particles in a framework of vibrating strings in higher dimensions, also suggests cyclic possibilities. In some string theory models, the universe undergoes repeated cycles of expansion and contraction, with each cycle lasting trillions of years. The extra dimensions of string theory, usually assumed to be compact and hidden, might undergo their own cycles, expanding and contracting on different timescales from our familiar three spatial dimensions. These cycles in the extra dimensions could drive cycles in our dimensions, creating a complex, multi-dimensional cosmic dance. But perhaps the most radical cyclic model comes from quantum mechanics itself. The Wheeler-DeWitt equation, which attempts to describe the quantum state of the entire universe, has solutions that suggest the universe might undergo quantum tunneling from one state to another. Just as an electron can tunnel through a barrier that classical physics says it shouldn't be able to cross, the universe might tunnel from a state of maximum expansion to a state of contraction, or from heat death to a new Big Bang. These quantum transitions wouldn't require any external cause or trigger. They would be spontaneous, driven by the fundamental uncertainty of quantum mechanics. The possibility of quantum regeneration becomes even more intriguing when we consider the role of consciousness and observation. In quantum mechanics, observation causes the collapse of the wave function, determining which of many possible states becomes actual. If consciousness plays a fundamental role in quantum mechanics, as some interpretations suggest, then perhaps conscious observers in the far future could influence how the universe transitions from one cycle to the next. This is highly speculative, but it raises profound questions about the relationship between mind and cosmos, between observers and the observed. Let me paint you a picture of what a cyclic universe might be like from the inside, from the perspective of beings like us who live within one cycle. We see a universe that began 13.8 billion years ago and is expanding toward an uncertain future. We can't directly observe previous cycles because the Big Bang or Big Bounce erases most information, resetting the cosmic clock. But we might find subtle hints, patterns in the CMB, anomalies in the distribution of galaxies, unexpected correlations that don't fit the single cycle model. These would be like finding fossils from before the supposed beginning of life, evidence that history extends further back than we thought. Each cycle might be similar in broad strokes but different in details. The fundamental constants of physics might vary slightly from cycle to cycle, determined by how the fields settle after each bounce or transition. One cycle might have stronger gravity, another weaker. One might have 3 spatial dimensions, another 4 or 2. The possibilities multiply, creating a kind of cosmic evolution where each cycle explores different regions of the space of possible physics. Our cycle, with its particular constants that allow atoms and stars and life, might be rare or common. We don't know. The duration of cycles might also vary. Some models suggest that cycles get longer with each iteration, the universe expanding more in each cycle than the last. Others suggest steady cycles, each one identical in duration to the others. Still others propose shortening cycles, the universe winding down like a bouncing ball that bounces lower each time. The observational evidence so far doesn't clearly favour any of these possibilities, leaving the nature of cosmic cycles, if they exist, an open question. There's something deeply satisfying about cyclic models, something that resonates with our experience of natural cycles, day and night, seasons, generations. They offer a kind of cosmic justice, where nothing is permanently lost, where every ending leads to a new beginning. They also resolve some philosophical puzzles about the universe's existence. Instead of asking why the universe began, which seems to require something from nothing, we can imagine it has always existed, cycling eternally through different phases. But cyclic models also raise their own puzzles. If the universe has been cycling forever, why is this cycle the way it is? Why hasn't it reached some equilibrium state that repeats exactly? The second law of thermodynamics suggests that entropy should increase from cycle to cycle, eventually leading to a heat death that can't be reversed. Cyclic models need to explain how entropy is reset, how the universe returns to a low entropy state ready for another cycle of cosmic evolution. Different models handle this differently, invoking quantum effects, extra dimensions, or new physics we haven't discovered yet. The possibility of cosmic cycles also connects to the idea of eternal return, the notion that if the universe repeats infinitely, then eventually it must repeat exactly, down to every detail. You, reading or listening to these words, would exist again in some future cycle, having the exact same thoughts, the exact same experiences. This is a vertigo-inducing idea that your life might be not unique, but one of infinite repetitions, each one identical, each one equally real. Some find this idea comforting, a kind of immortality through repetition. Others find it disturbing, suggesting a cosmic futility where nothing truly matters because it all repeats endlessly. But exact repetition might not be necessary or even possible. Quantum mechanics introduces fundamental randomness that might prevent any 2 cycles from being exactly identical. Each cycle might be a variation on a theme rather than an exact copy, like jazz musicians playing the same song differently each time. The universe might have a repertoire of possibilities that it explores without ever exactly repeating, infinite variation within bounded constraints. Observational evidence for cosmic cycles remains tantalizing but inconclusive. The anomalies in the CMB that some interpret as evidence for previous cycles or colliding universes can also be explained by more conventional physics. The patterns that some see as Hawking points from a previous ion might be statistical fluctuations or contamination from our own galaxy. The search continues, with new instruments and techniques promising better data in the coming years. But even if we never find definitive evidence for cosmic cycles, the possibility itself is profound. It means that our universe, rather than being a one-time event heading toward an inevitable death, might be part of an eternal process, a single movement in an infinite symphony. It means that the Big Bang might not be the ultimate beginning, but just our local beginning, and heat death might not be the ultimate ending, but just a transition to something new. Cyclic models also suggest that the universe might have a kind of memory, that information from previous cycles might survive in some form. This could be explicit, like the Hawking points in conformal cyclic cosmology, or more subtle, like the particular values of physical constants determined by how fields settled in previous cycles. We might be living in a universe shaped by countless previous universes, each one contributing to the conditions that allow our existence. The idea of cosmic rebirth also appears in scenarios that aren't strictly cyclic. For instance, Lee Smolin has proposed cosmological natural selection, where universes give birth to baby universes through black holes. Each baby universe has slightly different physical constants from its parent, like genetic mutations. Universes that produce many black holes have many offspring, while those that don't reproduce less. Over cosmic time, this leads to a kind of evolution, with universes becoming optimized for black hole production. Our universe, with its many black holes, might be the product of countless generations of cosmic evolution. Another possibility is that quantum fluctuations in the far future could spontaneously create new universes even in the heat-death state. These would be incredibly rare events, happening perhaps once every 10 or 120 years or some other unimaginably large timescale, but in an eternal universe approaching heat-death, even incredibly rare events will eventually happen. These baby universes might inflate and evolve independently, creating their own histories, their own possibilities for life and intelligence. There's also the possibility that advanced civilizations could deliberately trigger the creation of new universes, either to escape a dying cosmos or for other reasons we can't imagine. This is pure speculation, but it's consistent with known physics, at least in principle. By creating the right conditions, perhaps in particle accelerators, or through manipulation of black holes, intelligent beings might be able to nucleate baby universes that inflate into full-fledged cosmos. Our own universe might be the product of such deliberate creation, though this just pushes the question back to who created the creators. As we contemplate these possibilities of cosmic cycles and rebirths, it's natural to wonder what they mean for us, for consciousness, for meaning and purpose. If the universe cycles eternally, does that make our lives more or less significant? I would argue that it doesn't change the fundamental value of conscious experience. Whether you exist once or infinite times, whether the universe ends permanently or cycles forever, this moment of your awareness, your experience right now, is real and unique and precious. The cosmic context might be grander than we imagined, but that doesn't diminish the local reality of life and consciousness. In fact, cyclic cosmologies might offer a kind of ultimate hope. If the universe regenerates itself, if endings lead to beginnings, then perhaps nothing is ever truly lost. The patterns that make us who we are, the information that defines our consciousness, might re-emerge in future cycles, not as exact copies, but as themes and variations. We might be participating in a cosmic story that has no final chapter, where every ending is also a beginning, where death and birth are two faces of the same eternal process. The possibility of cosmic cycles also changes how we think about fine-tuning and the anthropic principle. Our universe seems remarkably well suited for the existence of complex structures like stars, planets, and life. In a single-shot universe, this fine-tuning seems to require explanation, perhaps through a multiverse or some deeper principle we haven't discovered. But in a cyclic universe, fine-tuning might emerge naturally through a kind of cosmic evolution or selection. Cycles that produce observers who can contemplate the universe might be more likely to lead to similar cycles, creating a kind of cosmic feedback loop. As we near the end of this chapter on cosmic cycles and rebirths, I want you to hold in your mind the image of the universe as a phoenix, dying and being reborn in endless succession. Each death is real, involving the dissolution of all structure, the erasure of all information, the end of all stories. But each death is also a transformation, a passage through which something essential survives to seed the next cycle. What that something is, whether it's energy, information, mathematical structure, or something we haven't conceived of, remains a mystery. The search for evidence of cosmic cycles continues with ever more sophisticated instruments and techniques. The next generation of CMB satellites might detect the gravitational wave signatures that would distinguish between different cyclic models. Observations of black holes might reveal whether they could be passages to baby universes. Studies of the fundamental constants might show whether they're truly constant or vary in ways that suggest previous cycles or parallel universes. But even without definitive evidence, the possibility of cosmic cycles enriches our understanding of existence. It suggests that the universe might be more creative, more resilient, more eternal than we imagined. It offers an alternative to both creation from nothing and heat death forever. a middle path where the universe neither begins nor ends but transforms eternally. It connects modern cosmology to ancient wisdom traditions that saw time as circular rather than linear, existence as cyclical rather than singular. Think about your own life in this context. You were born from the death of stars, assembled from atoms forged in stellar furnaces and scattered by supernovae. You will die, and your atoms will be dispersed, perhaps to be incorporated into new stars, new planets, new life. You are already part of a cycle, already participating in death and rebirth on a cosmic scale. The possibility that the universe itself cycles just extends this pattern to the largest possible scale, making the entire cosmos a participant in the same dance of transformation that governs all existence. As we prepare to transition from contemplating cosmic cycles to exploring the multiverse and its many possible endings, I want you to appreciate the profound shift in perspective we've undergone. We started with the idea of a universe with a definite beginning and a single ending. We've now seen that the universe might have no beginning, that it might have multiple endings, that those endings might lead to new beginnings in endless succession. The cosmos has revealed itself to be far more complex, far more creative, far more mysterious than we initially imagined. And we're not done yet. The cycles we've discussed so far assume that our universe, or our sequence of universes, is all there is. But what if our cycling cosmos is just one of many, perhaps infinitely many, each with its own patterns of death and rebirth, its own style of transformation? What if endings and beginnings proliferate not just in time, but across some larger space of possibilities? That's where our journey takes us next, into the Garden of Universes, the multiverse where every possible ending might be realized somewhere, somewhen, in ways we're only beginning to imagine. Scientists have suggested that our universe might be one bubble in a vast sea of bubbles, each with its own quiet fate, each one a separate cosmos floating in a larger reality that defies our imagination. Tonight, as we continue our journey through cosmic mysteries, we turn our attention to this most ambitious of ideas, the multiverse, where endings don't just multiply within our universe, but proliferate across countless universes, each one exploring its own path from birth to death, or perhaps from eternity to eternity. Imagine, if you will, not just a universe with multiple endings, but multiple universes each with their own endings, a garden of cosmos where every possible story plays out somewhere, where every potential fate is realized in some distant bubble of space-time. The idea of the multiverse emerges naturally from several different directions in modern physics, like multiple paths converging on the same destination. From cosmic inflation comes eternal inflation, the idea that the rapid expansion that started our universe never completely stops but continues forever in some regions, constantly creating new pocket universes. From string theory comes the landscape of possible vacua, perhaps 10,500 different ways the extra dimensions could be configured, each configuration creating a universe with different physical laws. From quantum mechanics comes the many worlds interpretation, where every quantum event branches the universe into multiple versions, each following a different path. These different approaches to the multiverse might be describing the same thing from different angles, or they might be pointing to different types of multiverses, layers upon layers of parallel realities. Let me paint you a picture of eternal inflation, perhaps the most developed and widely discussed multiverse scenario. Imagine space itself as a vast ocean, but instead of water, it's filled with a quantum field called the inflaton field. This field has energy even in its vacuum state, and this vacuum energy causes space to expand exponentially rapidly. In most regions, quantum fluctuations eventually cause the field to decay to a lower energy state, ending inflation and creating a pocket universe like ours, filled with matter and radiation. But inflation continues in other regions, and because the inflating regions expand so rapidly, they always dominate the total volume. New pocket universes are constantly being created, like bubbles forming in an infinitely boiling pot that never runs out of water. Each of these pocket universes can have different properties, determined by how the various quantum fields settle into their ground states when inflation ends. The strength of the fundamental forces, the masses of elementary particles, the number of spatial dimensions that are large versus compact, all these could vary from universe to universe. Some universes might be similar to ours, with stars and galaxies and the possibility of life. Others might be radically different, filled with black holes, or dominated by radiation, or structured in ways we can't even conceive. The multiverse becomes a vast experiment in possibility, exploring every combination of physical laws and constants. In this eternal inflation picture, our universe is just one bubble among infinitely many, and new bubbles are being created all the time, even right now, though far beyond our cosmic horizon, where we'll never observe them. Each bubble has its own beginning when inflation ends within it, its own Big Bang, its own cosmic history. And each bubble will have its own ending, or endings, depending on its particular properties and evolution. The multiverse doesn't have a single fate, but an infinite variety of fates, all playing out in parallel across the vast inflating space-time. Some bubbles might collapse in a big crunch after just a few billion years, their gravity overcoming their expansion. Others might expand forever, approaching heat death like our universe seems to be doing. Still others might undergo cyclic evolution, bouncing between expansion and contraction. Some might be torn apart by dark energy in a big rip. Some might undergo phase transitions that completely restructure their physics. The variety is endless, limited only by what's physically possible, and perhaps not even by that, since different bubbles might have different definitions of what's possible. The boundaries between these bubble universes are domains walls, regions where the inflaton field is transitioning from one state to another. These walls move at the speed of light from the perspective of someone inside a bubble, which means bubbles can collide. When two bubbles collide, the collision point creates a distinctive pattern that propagates through both bubbles. If our universe has collided with another bubble, we might be able to see the signature of that collision in the cosmic microwave background, a circular pattern with specific temperature variations. Some cosmologists have searched for such collision signatures, and while there have been tantalizing hints, nothing conclusive has been found yet. But the multiverse isn't just about different regions of space. It's also about different possibilities, different ways things could be. In quantum mechanics, every measurement, every observation, every quantum event involves a choice between different possible outcomes. In the many worlds interpretation, all these outcomes actually occur, each in its own branch of reality. When you measure the spin of an electron and find it's up, another version of you in another branch finds it's down. Both outcomes are real, both versions of you are real, existing in parallel branches that can never communicate with each other. If many worlds is correct, then the multiverse is unimaginably vast, with new branches being created every time a quantum event occurs anywhere in the universe. Since quantum events are happening constantly, countless times per second in every atom, every photon, every particle, the branching is explosive, exponential, creating a tree of realities with more branches than there are atoms in the observable universe. Each branch follows its own path toward its own ending, though branches that are similar might have similar endings, while branches that diverged early and dramatically might have completely different fates. This quantum multiverse adds another layer to our contemplation of cosmic endings. Not only might different regions of space have different endings, and different bubble universes have different endings, but different quantum branches of the same universe might have different endings. In some branches, unlikely quantum fluctuations might cause the universe to end sooner. In others, equally unlikely fluctuations might extend its life. Most branches might follow the statistical middle path, but the extremes are out there, realized somewhere in the vast quantum multiverse. String theory adds yet another dimension to the multiverse, literally. In string theory, the fundamental constituents of reality are not point particles, but tiny vibrating strings, and these strings need more than our familiar 3 spatial dimensions to vibrate in. The extra dimensions are usually assumed to be compact, curled up so small we don't notice them, but there are many ways they could be curled up, perhaps 10,500 different ways, each one creating a different vacuum state with different physics. This creates what's called the string landscape, a vast space of possibilities where each point represents a possible universe with its own laws and constants. Our universe occupies one point in this landscape, one valley in a vast mountain range of possibilities. But other universes might occupy other points, other valleys, each one as real as ours. Some theories suggest that universes can tunnel from one valley to another through quantum processes, changing their physics, essentially dying as one type of universe and being reborn as another. The landscape might be dynamic, with universes constantly exploring different regions, different possibilities, different ways of being. The variety of universes in the string landscape is mind-boggling. Some might have different numbers of large spatial dimensions, 2 or 4 or 7 instead of our 3. Some might have different numbers of fundamental forces, or forces with different properties. Some might have no atoms, or different kinds of atoms, or structures we can't imagine because they're based on physics too different from our own. Each universe would have its own story, its own evolution, its own ending or endings. As we contemplate this vast multiverse, it's natural to feel a bit overwhelmed, perhaps even insignificant. If there are infinite universes exploring every possibility, what makes our universe, our existence, special? But I would argue that the multiverse, rather than diminishing our significance, actually enhances it. We are the way this particular universe, with this particular physics, in this particular location, becomes conscious of itself. Our thoughts, our experiences, our choices are unique to this branch of reality, this bubble of space-time, this point in the landscape. We are not redundant copies, but unique expressions of cosmic possibility. Moreover, the multiverse might help explain why our universe seems so well suited for complexity and life. If there's only one universe, it seems miraculous that its constants are tuned just right for atoms to be stable, for stars to shine for billions of years, for chemistry to be rich enough to support life. But if there are countless universes with different constants, then it's not surprising that we find ourselves in one that allows our existence. We couldn't be having this conversation in a universe where atoms don't form or stars don't shine. This is called the anthropic principle, and while it's controversial, it offers a potential resolution to the fine-tuning puzzle. The multiverse also changes how we think about probability and prediction. In a single universe, we can ask about the probability of different outcomes, different futures, different endings. But in a multiverse where all possibilities are realized somewhere, probability takes on a different meaning. Instead of asking whether something will happen, we ask how often it happens, in what fraction of universes or branches or regions. This is called the measure problem in cosmology, and it's one of the deepest challenges in multiverse theories. Different universes in the multiverse might also have different arrows of time, different directions in which entropy increases. While our universe has a clear thermodynamic arrow pointing from past to future, other universes might have arrows pointing in other directions, or no clear arrow at all. Some universes might have multiple arrows pointing in different directions in different regions. Time itself becomes not a universal framework but a local phenomenon, different in each universe, each branch, each bubble. The endings of universes in the multiverse could be as varied as their beginnings and evolutions. Some might end in fire collapsing in a big crunch that returns them to infinite density. Others might end in ice, expanding forever toward heat death. Some might end in rips, torn apart by dark energy. Others might end in phase transitions, their physics suddenly changing in catastrophic ways. Some might not end at all, cycling forever or reaching stable configurations that last eternally. The multiverse becomes a laboratory for exploring every possible cosmic fate. There's something beautiful about imagining all these universes with their different endings, like a vast forest where every tree has its own shape, its own pattern of growth and decay. Some trees grow tall and straight, others twisted and gnarled. Some die young, struck by lightning or disease. Others live for centuries, becoming ancient giants. Some reproduce prolifically, scattering seeds that become new trees. Others stand alone, unique and unrepeated. The forest as a whole contains all these stories, all these possibilities, all these different ways of being a tree. The multiverse might also contain universes at different stages of their evolution. While our universe is 13.8 billion years old, approaching middle age in stellar terms, other universes might be much younger or much older. Some might still be in their infancy, filled with quasars and forming galaxies. Others might be in their old age, with all stars dead and only black holes remaining. Still others might have already reached their endings, whatever those endings might be. The multiverse becomes not just spatially vast, but temporally diverse, containing all cosmic ages simultaneously. Communication between universes in the multiverse is generally thought to be impossible. The boundaries between bubble universes expand at the speed of light, preventing any signals from crossing. Quantum branches decohere from each other, losing any possibility of interference or communication. different points in the string landscape are separated by energy barriers that would require cosmic scale energies to cross. Each universe is fundamentally alone, isolated in its own bubble of reality, unable to know directly about the others. But there might be indirect ways to infer the existence of other universes. Collisions between bubble universes could leave signatures in the cosmic microwave background. Quantum interference between nearby branches might be detectable in carefully designed experiments. Tunneling between points in the string landscape might leave traces in the form of cosmic defects or variations in fundamental constants. The search for such evidence is ongoing, pushing the boundaries of observation and theory. The multiverse also raises profound philosophical questions. If all possibilities are realized somewhere, does anything really matter? If every choice you make creates branches where you made different choices, do you have free will? If there are infinite copies of you in infinite universes, which one is the real you? These questions don't have easy answers, and different people find different resolutions. Some find the multiverse liberating, freeing them from the burden of thinking their choices have cosmic significance. Others find it meaningful that their choices determine which branch of reality they experience, even if other branches also exist. There's also the question of whether the multiverse itself could have an ending, a meta-ending that encompasses all the individual endings of component universes. Perhaps eternal inflation could stop everywhere simultaneously through some quantum phase transition. Perhaps all branches of the quantum multiverse could converge back to a single state. Perhaps the entire landscape could collapse to a single point. These possibilities are highly speculative, but they remind us that even our grandest theories might be incomplete, that there might be levels of reality beyond even the multiverse. As I describe these vast possibilities, I want you to remember that you are here, now, in this particular universe, experiencing this particular moment. The existence of other universes, if they exist, doesn't diminish the reality of your experience. You're not a statistical average across universes, but a unique conscious being in this specific branch of reality. Your thoughts, your feelings, your experiences are real and meaningful, regardless of what might be happening in parallel worlds you'll never observe. The multiverse also offers a kind of ultimate hope. If all possibilities are realized somewhere, then somewhere there are universes where suffering is minimized, where beauty is maximized, where consciousness flourishes and explores and understands. Somewhere there are universes that avoid heat death, that cycle eternally, that transform into new forms of existence we can't imagine. The multiverse contains all tragedies, but also all triumphs, all endings, but also all transcendences. Think about the creative potential of the multiverse. Every story that could be told is told somewhere. Every piece of music that could be composed is played in some universe. Every painting that could be painted exists on some parallel Earth. Every scientific discovery that could be made is made by some civilization in some bubble of space-time. The multiverse is the ultimate creative engine, exploring not just all physical possibilities, but all conscious possibilities, all experiential possibilities, all meaningful possibilities. As we near the end of this exploration of the multiverse and its many endings, I want you to appreciate the shift in scale we've achieved. We started thinking about the ending of our universe, a single cosmic story reaching its conclusion. Now we're contemplating infinite endings across infinite universes, a vast garden where every possible cosmic story plays out. Some universes end in darkness, others in light. Some end in simplicity, others in complexity. Some end soon, others in the deep future, still others never. The variety is endless, the creativity boundless, the possibilities infinite. But this vastness doesn't make our local story less important. If anything, it makes it more precious because it's unique, unrepeated exactly anywhere else in the multiverse. Your experience of listening to or reading these words, your contemplation of these ideas, your emotional and intellectual response to these possibilities, this is happening only here, only now, only in this branch of the quantum multiverse, this bubble of eternal inflation, this point in the string landscape. You're not lost in the vastness. You're a unique node of consciousness in the infinite network of reality. The multiverse, with all its parallel endings and possibilities, reminds us that existence is far richer, far stranger, far more creative than we ever imagined. It suggests that reality doesn't have to choose between possibilities but can explore all of them, that endings are not singular but multiple. that death and birth, ending and beginning, are happening constantly across the vast expanse of the multiverse. We are part of this cosmic creativity, this universal exploration of what can be, what can happen, what can end and begin and transform. As we prepare to bring our cosmic journey toward its own ending, or perhaps its transformation into something new, we need to consider what all these possibilities, all these endings and beginnings and cycles and parallels mean for us as conscious beings trying to make sense of our existence. How do we find meaning in a universe that might have no beginning and multiple endings? How do we understand our place in a possibly infinite multiverse? How do we live with the knowledge of cosmic endings, whether singular or multiple, whether near or far? These are the questions we'll explore as we bring our contemplation full circle. Perhaps our role is not to solve the universe, but to notice it, to feel it, to be the part that can wonder, the part that transforms cosmic evolution from a mere physical process into something witnessed, experienced, and contemplated. Here we are, you and I, tiny arrangements of atoms on a small planet orbiting an ordinary star in one galaxy, among trillions, contemplating the possibility that the universe has no beginning and multiple endings, that time itself might be emergent, that we might be one of infinite versions of ourselves across a vast multiverse. What does it all mean? How do we make sense of our brief lives in the context of such cosmic vastness? How do we find purpose when faced with the ultimate heat-death trillions of years hence, or the possibility of infinite cycles, or the existence of parallel universes where every possibility plays out? These are not new questions, of course. Humans have always wondered about their place in the cosmos, about the meaning of existence in the face of mortality and infinity. But modern cosmology has given these ancient questions new dimensions, new scales, new complexities. We're not just contemplating our mortality, but the mortality of the universe itself, not just our place in space, but our location in a possibly infinite multiverse, not just the mystery of existence, but the possibility that existence has no beginning and no singular ending. The scale of what we're contemplating can be overwhelming, can make human life seem impossibly small and brief and insignificant. But I want to suggest something different, something that might at first seem paradoxical. The vastness of the cosmos, the possibility of eternal cycles and parallel universes, the prospect of heat-death trillions of years in the future, rather than diminishing human significance, actually enhances it. We are the universe becoming conscious of itself, developing the ability to contemplate its own existence, to wonder about its own origins and fate, in a universe without verse, us, or without conscious beings like us. All these cosmic processes would unfold in darkness, unwitnessed, unknown, unappreciated. Stars would still shine, galaxies would still form, black holes would still evaporate, but there would be no one to see it, no one to wonder at it, no one to find it beautiful or terrifying or sublime. Think about it this way, and let this thought settle into your consciousness like starlight settling onto a quiet lake. Every atom in your body, except for hydrogen, was forged in the heart of a star that lived and died before our sun was born. You're literally made of star stuff, cosmic matter that has been recycled through generations of stellar evolution. But you're not just made of star stuff. You're star stuff that has awakened, that has developed eyes to see the stars it came from, a mind to understand the process that created it, a heart to feel wonder at the cosmic story of which it's a part. You're the universe looking back at itself, a mirror in which the cosmos can see its own face. This perspective transforms everything about how we understand human existence. We're not separate from the universe, looking at it from outside. We're part of it, expressions of it, manifestations of its tendency toward complexity and consciousness. When you contemplate the cosmos, it's the cosmos contemplating itself. When you feel awe at the vastness of space and time, it's the universe feeling awe at its own vastness. When you wonder about beginnings and endings, it's the universe wondering about its own nature. We are not insignificant specks in an indifferent cosmos. We are the cosmos becoming significant to itself. And if the universe has no beginning, if it's eternal in some sense, then we are part of an eternal process. The atoms that make us have always existed in some form, whether cycling through endless cosmic epochs or emerging from quantum fluctuations in eternal inflation. We are temporary arrangements of eternal stuff, brief patterns in an endless dance of matter and energy. Our lives are finite, but we're made of and embedded in something infinite. We are mortal beings made of immortal components, temporary songs sung by an eternal singer. The possibility of multiple endings, whether in different regions of our universe or in different universes across the multiverse, means that we're part of a creative exploration of possibilities. The universe isn't following a single predetermined script, but improvising countless variations, and we're part of that improvisation. Our choices, our actions, our very existence contributes to determining which of many possible futures becomes actual, at least in our region of space-time. We're not passive observers of cosmic evolution, but active participants in it. This participation isn't just physical, but conscious, meaningful, purposeful. Humans and perhaps other conscious beings throughout the cosmos are the way the universe develops purposes, goals, values. A universe without consciousness might evolve according to physical laws, but it wouldn't have purposes. Stars don't try to shine, they just shine. Galaxies don't want to form, they just form. But conscious beings do try, do want, do pursue goals and create meanings. Through us, the universe develops the ability to have intentions, to make choices, to create significance where none existed before. Consider what we've accomplished in our brief time as a conscious species. We've developed language, allowing us to share thoughts and experiences across space and time. We've created art and music and literature, expressing the beauty and tragedy and complexity of existence in forms that didn't exist before we created them. We've developed science and mathematics, discovering the laws that govern the cosmos and our place within it. We've built technologies that extend our senses across the electromagnetic spectrum and out to the edge of the observable universe. We've even begun to leave our home planet, taking our first tentative steps into the vast cosmos that created us. All of this has happened in just a few thousand years of civilization, an eye blink in cosmic time. If consciousness and intelligence continue to develop, whether in human form or otherwise, what might be accomplished in thousands or millions or billions of years? Perhaps we'll find ways to survive the heat death, to tunnel to new universes, to create baby universes, to transcend the apparent limitations of physics in ways we can't currently imagine. Perhaps consciousness will become a cosmic force, as significant as gravity or electromagnetism, shaping the evolution of the universe on large scales. Or perhaps not. Perhaps consciousness is destined to be a brief phenomenon, a temporary flowering of complexity that will fade as the universe approaches heat death. But even if that's true, it doesn't diminish the significance of consciousness while it exists. A flower is no less beautiful for being temporary. A piece of music is no less moving for having a beginning and an end. A human life is no less meaningful for being finite. In fact, it might be the temporality, the finiteness, the fragility of consciousness that makes it precious. The knowledge that the universe will eventually end, whether in heat death or some other scenario, can actually intensify our appreciation of the present. Every moment becomes more valuable when we know moments are limited. Every experience becomes more vivid when we understand it won't last forever. Every relationship becomes more precious when we recognize its impermanence. The cosmic perspective doesn't diminish human experience but enriches it, adding layers of significance and poignancy. Think about love in this context. When two people love each other, they create something that didn't exist before, a connection, a meaning, a purpose that emerges from their consciousness and relationship. This love might seem insignificant on cosmic scales, a tiny, emotional bond on a tiny planet in a vast universe. But it's also the universe creating something new, exploring a possibility that wouldn't exist without consciousness. Every act of love, kindness, creativity, or understanding is the cosmos adding to its own richness, its own meaning, its own value. The same is true for suffering and struggle. When we face challenges, overcome obstacles, endure pain, we're not just individual beings having difficult experiences. We're the universe exploring what it means to struggle and overcome, to suffer and endure, to face adversity and grow from it. Our struggles are cosmic struggles, our growth is cosmic growth, our learning is the universe learning about itself through us. This doesn't mean we should accept suffering passively or view pain as cosmically necessary. We can and should work to reduce suffering, to increase well-being, to create conditions where consciousness can flourish. But it does mean that even our struggles have cosmic significance, that they're part of the universe's exploration of its own possibilities, its own potential for growth and transformation. The possibility that we're in a multiverse where every possibility is realized somewhere adds another dimension to human significance. If every choice creates branches where different choices were made, then our decisions literally shape reality, determining which branch we experience. We're not just choosing what to do, we're choosing which universe to inhabit, which version of reality to make actual for ourselves. Every decision, no matter how small, is a cosmic decision, a selection from the infinite possibilities of the multiverse. This might seem to imply that our choices don't matter, because all possibilities are realized somewhere, but I would argue the opposite. Our choices matter precisely because they determine our path through the multiverse, our experienced reality, our actual story. The fact that other versions of us might be making different choices in other branches doesn't diminish the importance of our choices in this branch. We are the authors of our own cosmic story, even if other authors are writing different stories elsewhere. The endless nature of the universe, whether through cycles, multiverses, or eternal inflation, also suggests that consciousness might be a recurring phenomenon, appearing again and again in different forms, different contexts, different universes. We might be part of an eternal pattern, a cosmic tendency toward awareness that manifests whenever conditions allow. Consciousness might be as fundamental to the universe as matter and energy, an inevitable emergence given sufficient complexity and time. If consciousness is indeed a fundamental feature of the cosmos, then death takes on a different meaning. Individual consciousness ends, but consciousness itself continues, emerging in new forms, new beings, new universes. We are waves in an ocean of consciousness, temporary but part of something, permanent. Our individual waves will break and dissipate, but the ocean continues and new waves will form, each unique but all part of the same vast sea. This view connects to ancient spiritual and philosophical traditions that see consciousness as fundamental, eternal, divine. But it's also consistent with modern scientific understanding of emergence, complexity, and information. Consciousness might be what happens when information processing reaches a certain level of complexity and self-reference. And since the universe seems to naturally evolve toward greater complexity, at least locally and temporarily, consciousness might be a natural, inevitable product of cosmic evolution. The question of meaning in a universe with no beginning and multiple endings ultimately comes down to this. Meaning is something we create, not something we discover. The universe doesn't hand us a predetermined purpose. It gives us the capacity to create purposes. We are meaning-making beings in a cosmos that allows meaning to be made, and the meanings we create, the purposes we pursue, the values we embody, these become part of the universe's story, part of its exploration of what it can be. This is both a tremendous responsibility and a tremendous opportunity. We are not following a cosmic script but helping to write it. We are not discovering our purpose but creating it. We are not finding meaning but making it. And the meanings we make, the purposes we create, the values we embody, these ripple out from us, affecting others, shaping the future, contributing to the cosmic story in ways we might never fully understand. Consider the impact of a single human life, your life in this cosmic context. Every person you interact with, every idea you share, every action you take creates ripples that spread outward through space and time. A kind word might change someone's day, which changes their interactions with others, which affects their decisions, which shapes their future and the futures of everyone they touch. These ripples spread and interfere and combine with ripples from other lives, creating patterns of causation and influence that extend far beyond what we can track or imagine. In a universe heading toward heat death, these ripples might seem to fade and disappear, lost in the cosmic expansion and cooling. But if the universe cycles, if information can pass from one cycle to the next, then perhaps some essence of our actions, some pattern of our influence, continues beyond the apparent ending. If the multiverse is real, then our ripples create branches, spawning new universes where our influence plays out differently. We might be more cosmically significant than we can possibly imagine. But even if our ripples do eventually fade, even if no trace of our existence survives the heat death or the next cosmic cycle, the fact that we existed, that we experienced, that we created meaning, this fact is eternal. It will always be true that in this region of space-time, consciousness emerged and flourished. It will always be true that beings like us wondered about the cosmos and our place in it. It will always be true that love and beauty and understanding existed here, now, in us. These truths are written into the structure of space-time itself, permanent features of the cosmic story, even if no one remains to remember them. As we contemplate our place in this vast, possibly eternal, possibly multiple cosmos, it's natural to feel a mix of emotions. There's vertigo at the sheer scale of it all, humility at our tiny place in the vastness, awe at the complexity and beauty of cosmic evolution. There might be fear of our cosmic insignificance, sadness at the impermanence of everything we know and love, anxiety about the ultimate fate of the universe. But there can also be wonder, gratitude, even joy at being part of something so vast and mysterious and beautiful. The cosmic perspective doesn't solve our human problems or eliminate our human concerns. We still need to navigate relationships, pursue goals, deal with suffering, find happiness. But it does provide a context, a framework, a perspective that can inform how we approach these very human challenges. Knowing that we're part of something vast and ancient and ongoing can give us strength in difficult times. Understanding that consciousness is precious and possibly rare can motivate us to protect and nurture it. Recognizing that we're all made of the same cosmic stuff, all part of the same universal process, can foster compassion and connection. The possibility that the universe has no beginning and multiple endings also invites us to think differently about time and change. Instead of seeing time as a resource that's running out, we can see it as a dimension we're moving through. Instead of fearing change as loss, we can embrace it as transformation. Instead of clinging to permanence, we can appreciate impermanence as what allows new things to emerge. The cosmic perspective doesn't eliminate our human concerns, but can transform how we relate to them. As we near the end of this contemplation of what cosmic vastness means for human existence, I want to return to where we started. You, here, now, experiencing this moment. All the cosmic scales and possibilities we've discussed, all the billions of years and light years, all the parallel universes and cosmic cycles, they all converge in your consciousness at this moment. You are the point where the universe becomes aware of itself, where cosmic evolution becomes conscious experience, where physical processes become thoughts and feelings and wonder. Your life matters not because of its duration compared to cosmic time, or its size compared to cosmic space, but because it's a unique instantiation of consciousness, a unique perspective on existence, a unique contribution to the cosmic story. You will never be repeated exactly, even in an infinite multiverse, because you are not just your physical configuration, but your entire history, your experiences, your relationships, your choices, all of which are unique to this branch of reality, this bubble of space-time, this moment in cosmic evolution. The universe has invested 13.8 billion years of evolution in creating you, in arranging atoms and energy in precisely the pattern that is you at this moment. Stars had to live and die, galaxies had to form and evolve, our solar system had to coalesce from a cloud of gas and dust, Earth had to develop the right conditions, life had to emerge and evolve through countless generations, all to produce you, here, now, capable of contemplating your own existence and the existence of the cosmos that created you. This is not to make you feel burdened with cosmic responsibility, but to help you appreciate the profound gift of your existence. You're not an accident or an afterthought, but a culmination, a fruition, a realization of cosmic potential. Through you, the universe experiences what it's like to be human, to have your particular perspective, to face your particular challenges, to create your particular meanings. No one else can do this for the universe. Only you can be you. Only you can contribute your unique verse to the cosmic poem. As we prepare to conclude our journey, to bring together all the threads we've woven about beginnings and endings and cycles and multiverses, remember that understanding our cosmic context doesn't diminish our humanity, but enriches it. We are not less for being small, but more for being conscious. We are not insignificant for being temporary, but significant for existing at all. We are not meaningless in a vast cosmos, but are part of how the cosmos creates meaning. We are the universe understanding itself, celebrating itself, questioning itself, and perhaps, in some small way, determining its own fate.